How about global thermonuclear war?
Hey there, HackerFrogs. It's me, the Shy Hat, and we're doing HackerFrogs free hacking today. We're doing HackerFrogs after school. We're hacking all the things. We're hacking all the things. Thank you very much, Raiders from E to the 2IPI. Thank you very much for the raid. But anyways, my name is the Shy Hat. We're here to do cybersecurity stuff and tech stuff on Twitch and on YouTube. And let's talk about what we're going to be doing today. So today is week 18 of 2026. It seems like the year is just flying on by. And we're doing Wednesday, April 29th, 2026. And we're doing the first stream of this week. But let's talk about what we're going to be doing today. So on each one of these live streams, we like to cover a number of different topics. And today we're going to be starting off with our AI Basics course. We're doing a course over at elementsofai.com. And we've been learning a little bit about AI because it seems to be the thing that has taken over everybody's. You mean it's not 2018? No, not anymore. It hasn't been for a while. But anyways, that's the first thing we're going to be doing today. In the second hour of today's stream, we're going to be doing some demos from PicoCTF 2026. This is a CTF event, a cybersecurity challenge event that happened back in March, and we're going to be going over some of the challenges and explaining how these challenges work. So that's going to be in the second hour of today's stream. In the third hour, we're going to be doing HackerFrogs AfterSchool, which is a course that I come up with to learn all about basic cybersecurity skills. We're wrapping up our web app basics course, and we're going to be learning about how to use Burp Suite, the most popular web app security tool. So that's what we're going to be doing in the third hour of today's stream. In the fourth hour, we're going to be doing some Sherlock challenges. So these are going to be defensive-oriented digital forensics challenges over at the HackTheBox website. So, I mean, I really want to cover more HackTheBox stuff, but my mission on this channel is to cover stuff that is both free to users and also evergreen content. And there's not as much of that kind of content over at HackTheBox, but we've got a bunch of Sherlock challenges, forensics challenges to look over there. So that's going to be the fourth hour of today's stream. The last thing we're going to be doing is we're going to be going back to a challenge we were doing last week, and the challenge was called Latestwasalie, and this is a Docker-oriented Linux challenge, and we're going to be trying to finish off that box today. But anyways, without further ado, let's get into the first topic for the day. This is going to be our study of AI topics. So let's go ahead and get started. I'll provide everybody with the links for the course that I'm doing, and let's go ahead and get started over there. So we're doing this portion of the course. I'm pretty sure that anybody can take a look at this without being logged in, but let me just double check that. Okay, so it looks like, yeah, you don't need to be logged in to see this content, but if you are logged in, you can keep track of your progress. Anyways, let's get into it. So this is Elements of AI. This is chapter 3 out of 6 chapters, and we're doing the second section of this particular chapter. So what we're learning about right now is the Bayes rule. So I'm going to be reading out aloud and trying to follow along with the exercises, and I hope we can all learn something together. So this is the Bayes rule, or the Bayes rule. I'm not too sure how to pronounce this name. If anybody knows in chat how to pronounce this name, Bayes or Bayes, let me know. We will not go too far into the details of probability, calculus, and all the ways in which this can be used in various AI applications, but we will discuss one very important formula. Bayes. Oh, okay, thank you very much. E to the 2pi, that's how I usually say it, okay? Have you taken these kind of probability courses before, or learned about AI? Just curious, because I'm a complete newbie to this, and well, this is why we're trying to go through the course. Yeah, I have. Okay, that's great. That's great, and thank you very much for the raid earlier. Let's go ahead and give your channel a shout out. So shout out E to the 2pi, and let me know what you were doing on your stream. Because, I mean, do you also do cybersecurity content on Twitch and on YouTube? Okay, we will do this particular formula. We will do this because this particular formula is both simple and elegant as well as incredibly powerful. It can be used to weigh conflicting pieces of evidence in medicine and a court of law, and in many, if not all, scientific disciplines. Okay, not so much that I do math content, but I also do web development. Okay, so another tech creator. That's great. So the formula is called the Bayes rule, or the Bayes formula. We will start by demonstrating the power of the Bayes rule by means of a simple medical diagnosis problem, where it highlights how poorly our intuition is suited for combining conflicting evidence. We will then show how the Bayes rule can be used to build AI methods that can cope with conflicting and noisy observations. Key terminology: prior and posterior odds. The Bayes rule can be expressed in many forms. The simplest one is in terms of odds. The idea is to take the odds for something happening against it not happening, which we will call prior odds. Take the odds for something happening against it not happening, which is called prior odds. The word prior refers to our assessment of the odds before obtaining new information that may be relevant. The purpose of this formula is to update the odds when new information becomes available to obtain the posterior odds, or the odds after obtaining the information. The dictionary meaning of posterior is something that comes after or later. So prior and posterior odds, so the odds before and the odds after. Okay? So let's learn a little bit more about this. So how odds change. In order to weigh the new information and decide how the odds change when it becomes available, we need to consider how likely we would be to encounter this information in alternative situations. Let's take as an example the odds that it will rain later today. Imagine getting up in the morning in Finland. The chances of rain are 206 and 365, including rain, snow, and hail, burr. The number of days without rain is therefore 159. This converts to prior odds of 206 to 159 for rain, so the cards are stacked against you already before you open your eyes. Okay, so, however, after opening your eyes and taking a look outside, you notice it's cloudy. Suppose the chances of having a cloudy morning on a rainy day are 9 out of 10. That means that only 1 out of 10 rainy days start out with blue skies, but sometimes there are also clouds without rain. The chances of having clouds on a rainless day are 1 in 10. Now, how much higher are the chances of clouds on a rainy day compared to a rainless day? Think about this carefully, as it will be important to be able to comprehend the question and obtain the answer in what follows. The answer is that the chances of clouds on a rainy day are 9 times as high as the chance of clouds on a rainless day. On a rainy day, the chances are 9 out of 10, whereas on a rainless day, the chances are 1 out of 10, which is 9 times as high. Note that even though the two probabilities, 9 out of 10 and 1 out of 10, sum up to 9 out of 10 plus 1 out of 10 equals 1, this is by no means always the case. In some other town, the mornings of rainy days could be cloudy 8 times out of 10. This, however, would not mean that the rainless days are cloudy 2 times out of 10. You'll have to be careful to get the calculations right. But never mind if you make a mistake or two, don't give up. The Bayes rule is a fundamental thinking tool for every one of us. Okay, so while we do this particular course, let's go ahead and put on some music, because it's always a little bit better to study just some music. Let's go ahead and put on, I don't know, how about this music over here? Okay, and we'll make that a little bit softer. Okay, so what are we talking about next? We're talking about the likelihood ratio. The above ratio, 9 times as high chances of clouds on a rainy day compared to a rainless day, is called the likelihood ratio. More generally, the likelihood ratio is the probability of the observation in case the event of interest in the above rain, divided by the probability of the observation in the case of no event in the above no rain. Please read the previous sentence a few times. It may look a little bit intimidating, but it's not impossible to digest if you just focus carefully. We will walk you through the steps in detail. Just don't lose your nerve. We're almost there. Okay, so let's go over this one more time. So the above ratio, 9 times as high chances of clouds on a rainy day compared to a rainless day, are called the likelihood ratio. So likelihood ratio is... So two probabilities are clouds on a rainy day. Okay, so let's do a little bit of note taking over here. So this is clouds on a rainy day. So this is 9 out of 10 times there are clouds on a rainy day. And the second one is which one? Okay, clouds on a rainless day are 1 out of 10. Clouds on a rainless day. So this is 1 out of 10 times. Okay, so these are our likelihood ratios. Okay, so let's see. The above ratio is called the likelihood ratio. More generally, the likelihood ratio is the probability of an observation in case the event of interest divided by the probability of the observation in the case of no event. Okay, so we concluded that on a cloudy morning, we have a likelihood ratio equals 9 out of 10 divided by 1 out of 10 equals 9. So let's see. So likelihood ratio is this number, so the first number divided by the second number. So likelihood ratio is so 9 out of 10 divided by 1 out of 10. So 9 out of 10 divided by 1 out of 10, so that's... So 9 out of 10 is 0.9. So that would be 0.9 divided by 0.1. 0.9 divided by 0.1. So because I'm not very good at math, I can go ahead and grab like a calculator online. So this would be 0.9 divided by 0.1, and this is equal to 9. Well, I mean, they tell us in the article over here. So we conclude that on a cloudy morning, we have likelihood ratio equals 9. Likelihood ratio equals 9. So how does this relate? So the mighty Bayes rule for converting prior odds into posterior odds is, ta-da, as follows. Posterior odds equals likelihood ratio times prior odds. Likelihood ratio times prior odds. Okay, so we should probably record this if we're going to be making some notes later. So posterior odds equals likelihood ratio times prior odds. I mean, I guess we can use this symbol over here because it's more familiar to us. Okay, now you're probably thinking, hold on, that's the formula? It's just a single multiplication. That is the formula. We said it's simple, didn't we? You wouldn't imagine that a simple multiplication can be used for all kinds of incredibly useful applications, but it can. We'll study a couple of examples which will demonstrate this. So the prior odds, posterior odds equals likelihood ratio times prior odds. I mean, didn't we do a calculation just like this? So in this case, we're talking about clouds on a rainy day versus clouds on a rainless day. So this is posterior odds are going to be this 1 out of 10. So 1 out of 10 equals likelihood ratio 9 times prior odds, and the prior odds are 9 out of 10. So 9 out of 10, and of course 9 out of 10 is equal to 0.09, and this is 0.1. So 0.1 equals 9 times 0.9. I mean, 9 times, yeah, okay, the math seems to, let me just punch these into the calculator. So 9 times 0.9. Sorry, did I get this? So we got the likelihood ratio over here. So, anyways, we'll come back to this. Maybe I'm getting my my numbers wrong. Okay, the many forms of Bayes. In case you have any trouble with the following exercise, you may need to read the above material a few times and just give it some time. And if that doesn't do it, you can look for more material online. Just a word of advice, there are many different forms in which the Bayes rule can be written, and the odds form that we use isn't the most common one. Here are a couple of links that you may find useful. So, okay. So let's just copy, well, I'll copy these to the chat in case you want to take a look. Oh, these are YouTube videos. Or one of them's a YouTube video. Okay. So, exercise 10, the Bayes rule, part 1 and 2. Apply the Bayes rule to calculate the posterior odds for rain having observed clouds in the morning in Helsinki. As we calculated above, the prior odds for rain is 206 out of 159, 206 to 159, and the likelihood ratio for observing clouds is 9. Oh, okay. So these are odds. So these... Okay. So let me just copy this. So we determined last time that if we have odds like this, we can convert these odds into a percentage. By adding up these two numbers. So this number plus this number, and I think this number comes out to 365. And we have to do a division. So division of the... so this is rain to no rain. So we divide 206 by 365. 206 divided by 365 to get a percentage. So 206, 365. 206, 365. So this is 56%. So there's a 56% of rain, so 0.56. So it is rainy. It is rainy 206 days of the year out of 365 days, and is not rainy 159 times out of 365. Is this really the percentage though? Okay, so we're looking at... So we calculate the prior odds for rain, and the likelihood ratio for observing clouds is 9. So let's see. Give your result in the form of odds XX, YY, where XX and YY are numbers. Note that XX and YY do not mean that the numbers should have 2 digits each. Remember that when multiplying odds, you should multiply the numerator, the XX part. For example, if you multiply the odds 5 to 3 by 5, The result is 25 to 3. 25 to 3. Give the answer without simplifying the expression, even if both sides have a common factor. Huh. Okay, so I think what they want... So they just want us to multiply this number by 9. So 206... Okay, so if we go back... These are the odds here, and we need to multiply this by... So the prior odds are this right here. These odds right here. We need to multiply this by the likelihood ratio, which we calculated out to be 9. So we're multiplying this number by 9. So 206 times 9. Anyways, let's get the number from our calculator. So this is 206 times 9. Okay, so this is 1,000, so it's 1854. 1854 to 159, like this. So give the results in the form of odds x, x, y, and y, where x, x, and y are numbers. Okay? Remember that when you're multiplying odds, you should only multiply the numerator, the xx part. So if you multiply the odds 5 to 3 by 5, the result is 25 to 3. Give the answer without simplifying the expression. Okay, so the answer in this case would be this number right here. Okay, hopefully this is correct. I'm not a math person, but it doesn't seem to be super complex. Submit this. Your answer is correct. The prior odds are 206 to 159. The likelihood ratio is 9, so we get the posterior odds for rain given that for given clouds to be 9 times 206 to 159 equals 1854 to 159. So in the long run, on the days when we observe clouds in the morning, we can expect 1854 rainy days for every 159 rainless days, which is about the same as 12 rainy days for one rainless day. If we wanted to express this as a probability, even though that was not the question, we could use the formula x divided by x plus y to get the value 1854 divided by 1854 plus 159, which is about 0.92, or about a 92% chance of rain when there are clouds in the morning. Better take an umbrella. Okay, so this makes sense. This makes sense to me, so we might as well move on to the next section. Okay, many students fail at this exercise. Really? I wonder why many students would fail at this exercise. That's normal. The real goal isn't to score perfect points, it's to wrestle with the ideas, to see how math and algorithms connect and build a deeper understanding for the chapters to come. So please don't get discouraged if you get stuck and make mistakes. Take your time, reread the materials, ask questions, discuss with others. Keep going, you've got this. Okay, so the Bayes rule in practice. Breast cancer screening. Our first realistic application is a classic example of using the Bayes rule, namely medical diagnosis. This example also illustrates a common bias in dealing with uncertain information called the base rate fallacy. Okay, so population before diagnosis. So we're talking about breast cancer. So population before diagnosis. So we're talking about 100 people, and there's like 1, 2, 3, 4, 5. 5 and 100. I'm guessing that's 100. Population after diagnosis. So there's... I'm not too sure how to read this chart, but I guess they'll talk about it in the material below. Consider mammographic screening for breast cancer using made-up percentages for the sake of simplifying the numbers. Let's assume that 5 in 100 women have breast cancer. Suppose that if a person has breast cancer, then the mammograph test will find it 80 times out of 100. Okay? When the test comes out suggesting that breast cancer is present, we say that the result is positive, although of course there is nothing positive about this for the person being tested. A technical way of saying this is that the sensitivity of the test is 80%. Okay. So if we test 100 women, and 5 of them have breast cancer, and the test finds it 80% of the time, that means that the test will work 80% of the time where it is present. So 80% of the time in 5 is like 4 out of 5. So 4 out of 5 times we detect it. Sysoma says, after diagnoses, there are still people with breast cancer not found, so the two groups still contain people with breast cancer. The two groups still contain people with breast cancer. So the negative population, or the negative group here, still has a person with breast cancer, even though they were tested, because the testing didn't detect it. But the ones where... Oh. Are we saying that it did false positives as well? So for the population with breast cancer, 1, 2, so 80% of them were found, but there was also false positives in here, so it looks like. Okay, the test may also fail in the other direction, namely to indicate breast cancer where none exists. This is called a false positive reading, or a false positive finding. Suppose that if a person being tested actually doesn't have breast cancer, the chances that the test nevertheless came up positive are 10 in 100. In technical terms, we would say that the specificity of the test is 90%. Okay, so based on the above probabilities, you're able to calculate the likelihood ratio. You'll find use for it in the next exercise. If you forgot how the likelihood ratio is calculated, you may wish to check the terminology box earlier in this section and revisit the rain example. Note, you can use the above diagram with stick figures to validate that your result is in the ballpark about right, but note that the diagram isn't quite precise. Out of the 95 women who don't have cancer, the gray figures in the top panel, about 9.5 are expected to get a false or positive result. The other 85.5% are expected to get a true negative result. We didn't want to be so cruel as to cut people, even stick figures, in half, so we use 9 and 86 as an approximation. Okay, so they're rounding up and down, I guess, in these examples. Okay, so exercise 11, Bayes rule, part 2 of 2. Consider the above breast cancer scenario. An average woman takes the mammograph test and gets a positive test result suggesting breast cancer. What do you think are the odds that she has breast cancer, given the observation that the test is positive? First, use your intuition without applying the Bayes rule and write down on a piece of paper, not in the answer box below, what you think the chances of having breast cancer are after a positive test result. The intuitive answer will not be a part of your answer, it's just for your own information. Next, calculate the posterior odds for her having breast cancer using the Bayes rule. This will be your answer. Okay, so we'll figure that out in just a second, but first we'll answer this question. Okay, write down on a piece of paper, what do you think the chances of having breast cancer are after a positive test result? The intuitive answer will be a part of your answer. Okay. Okay, yay security. Hello, nice to see you here. Am I too late? What we have tonight? So we're talking about AI stuff right now. We're talking about probability and the Bayes rule. If you want to take a look at what we're looking at right now, this is it right here. If you want to take a look at what else we have on the schedule, you can take a look at this Reddit thread here. Alright, so what we're trying to do is we're just going to ballpark what the chances are of having breast cancer after getting a positive result. So breast cancer odds after positive test result. Okay, so if we're given this information here, so we know that the population before diagnosis looks like this. They haven't been split up yet, and there are 5 women who have breast cancer in this population. So after the diagnosis, there's still 1 person with breast cancer who got who was misdiagnosed, and there are 4 people with breast cancer who got passed in. So what are the chances of you actually having breast cancer here? Because we saw that a bunch of people without breast cancer also got lumped into the same group. So we got 1, 2, 3, so it's 6, 9, 11, 13. So there's 13 women here who got passed into the positive group. So out of those 13, only 1, 2, 3, only 4 of them actually have the breast cancer. So if you get a positive result, the instinct is that you've got a 4 in 13 chance, or a 4 in 13 chance. Chance, or this would be called 3 to 10 odds. So this is the intuitive answer. Okay, SysOS says, after a single positive test result, by the way, in medicine, typically 2 tests are done before diagnosing. I mean, you'd probably want to do that to rule out false positives. So if you get a positive result at first, then you test again, just to make sure you actually have the breast cancer or don't have the breast cancer. That makes more sense. So we're trying to figure out the following things. So we start by calculating the prior odds. Okay, so what is our answer? Enter the posterior odds as your solution below. So we know that posterior odds equaled likelihood ratio times prior odds. So what we need to do is we need to calculate the posterior odds here. So the first thing we need to do is, let's see, SysOS says they typically also use 2 different means if possible. A false positive in one is much more likely than one in 2 methods. So they use 2 different methods to try to figure out if there are, to figure out whether a true diagnosis, right? So likelihood ratio times prior odds. So the prior odds is going to be, so the prior odds seems to be like 5 out of 10, 5 out of 100, right? 5 out of 100, or five to 95. So the prior odds are 5 to 95. So are we trying to figure out doesn't have breast cancer or does have breast cancer? So this is has breast cancer is 5 to 95. So these are our prior odds. Our likelihood ratio is going to be the likelihood ratio is has breast cancer after getting diagnosed versus has breast cancer versus doesn't have breast cancer after getting diagnosed. So if it's has breast cancer after getting diagnosed, that would be 5 out of 13? No, wait, 4 out of 13. So 1, 2, 3, so 6, 9, 11, 13. Four out of 13, or this is expressed as 4 to 9 odds. This is 4 to 9 odds, or this expressed as so it is 4 divided by 13. Yeah, 4 divided by 13 is the percentage. So this is 4 divided by 13, which is 30%. I mean, where do we cut this off? Let's just call this 0.307. So if this is 30.307, if we were to convert this into a percentage, will we round up or would we round down? Let's just chop this off. So let's just make this 0.3. So your likelihood of having breast cancer, this is only 30%. So your prior odds are only like 30% of having breast cancer after getting diagnosed. Okay, what is your OS? So we're currently using Kali Linux. So the answer is Kali Linux, which is a type of Debian Linux. So the likelihood ratio is prior odds, is it multiplied? Posterior odds equals likelihood ratio times prior odds. Here we're doing, so it's 30% divided by the likelihood you do have it. So it's 0.3 divided by, so the likelihood that you do have it in this case is 9 to no. Prior odds 5%. Kali Linux, why? It's better than Linux Mint. I mean, I don't know too much about Linux Mint. It's just I use Kali Linux because it's got all the cybersecurity tools. I mean, I use a lot of Linux. It's just that I don't use it as my daily driver. But in Iniesta, hello, nice to see you here. Kali Linux only. I mean, I'd say that I mostly stick to Debian, to like Debian-based versions of Linux, and I think Linux Mint is a Debian-based version of Linux. I could be wrong, but let me look that up real quick. Okay, most Linux Mint editions are based in Ubuntu, not directly on Debian. So, I mean, Linux Mint, the one that you're mentioning right now, it is based on Ubuntu, and Ubuntu is based on Debian. So, I mean, I'm using something that's a lot closer to Linux Mint than some other stuff. Discord? Yeah, we've got a Discord if you want to take a look. Over here. But what were you talking about? So the population after diagnosis. So the population, so the likelihood that you do have it is this cohort right here, and the likelihood that you don't have it is this cohort right here. So this is the chance that you have it when you don't. So that's like, how many is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it's 18 times 2, and then 18 times 2, and then 17 times 3. $18 times 2 plus 17 times 3. So this is 87 people. So out of 87 people, one person does have the breast cancer. So these are the odds. So one out of 87. Give me priority roll on Discord. I'm afraid I can't do that. Okay, so the likelihood ratio, if you get diagnosed versus don't get diagnosed, is 1 out of 87. So what is 1 out of 87? How many percentage is that? So this is going to be 1 divided by 87, which is 0.1%. So the chances of you having breast cancer after getting a negative diagnosis is 1%. Okay, so 1%. So this is 0.01. I'm pretty sure I've got the math completely wrong here. We need to calculate the likelihood ratio in this case. Likelihood ratio is going to be a like a number. So it's going to be this number divided by this other number. Let's check the math for this before we go through with this calculation. Okay, prior odds for rain are this, and the likelihood ratio for observing clouds. So the likelihood ratio for observing clouds is going to be positive 9 out of 10. So positive 3 out of 10 divided by like some really small number. So it's 30% versus 1%. So it's 0.3 divided by 0.01. Okay, let's do the calculations. So it's going to be 0.3 divided by 0.01, and the result is 30. Oh, so we multiply whatever it is by 30, because this is the likelihood ratio. So this is equal to 30, and then we need to calculate the posterior odds. So the likelihood ratio, which is 30, times the prior odds. So the prior odds is 5 out of 100, or 5 to 95. So it would be 5 to 95 times 30, and the result of this is 30 times, this is 150 to 95. So this is what I think the answer is. I'll try submitting this. I might have my math completely wrong, but we'll figure it out. But in the meantime, before we do that, let's go ahead and put on some music. Okay, what makes you special enough to get priority roll in Discord? I'm not too sure. Being a good member of the community? That's my guess. Okay, let's submit this as the answer. So 150 to 95. Okay, submit. The answer is not correct. Okay, so let's figure out what the actual odds are. So incorrect, your prior odds describe the situation before getting the test results. Since 5 out of 100 women have breast cancer, there is on average 5 women with breast cancer for every 95 women without breast cancer, and therefore the prior odds are 5 to 95. Oh, okay. Yeah, no. I understand now after rereading the message. Thank you. Okay, the likelihood ratio is the probability of a positive result in case of cancer divided by the probability of a positive result in case of no cancer. With the above numbers, this is given by 80 out of 100 divided by 10 out of 100. So 80 out of 100 divided by 10 out of 100, which is 8. The Bayes rule now gives the posterior odds of breast cancer given the positive test result. Posterior odds equals 8 times 5 to 95, which is 40 to 95, which is the correct answer. So 40 to 95 is the correct answer. So despite the positive test result, the odds are actually against the person having breast cancer. Among the women that are tested positive, there are on average 40 women with breast cancer for every 95 women without breast cancer. Okay, so among the women who tested positive, there are on average 40 women with breast cancer for every... So that seems pretty low. It's pretty much 50%. It's pretty close to 50%. And that's not a great... It doesn't seem like a very accurate test. Note, if you would like to express the chances of breast cancer given the positive test result as a probability, even though this is not what the exercise asked for, we would consider the 40 cases with cancer and the 95 cases without cancer together, and then calculate what portion of the total, 40 plus 95, 135 individuals have cancer. This gives the result 40 out of 135, or about 30%. This is much higher than the prevalence of breast cancer, 5 in 100 or 5%, but still the chances are that the person has no cancer. If you compare the solution to your intuitive answer, they tend to be quite different for most people. This demonstrates how poorly suited our intuition is for handling uncertain or conflicting information. So, yeah, that seems pretty bad. So the base rate fallacy. So while doing the above exercise, you may have noticed that our intuition is not well geared towards weighing different pieces of evidence. This is true especially when the pieces of evidence conflict with each other. In the above example, on one hand, the base rate of breast cancer was relatively low, meaning that breast cancer is relatively rare, so our brain thinks that it's unlikely that a person has it. On the other hand, the positive mammograph test suggests the opposite. Our brain tends to choose one of these pieces of evidence and ignore the other. It is typical the low base rate that is ignored. That's why your intuition probably says that the posterior probability of having breast cancer, given the positive test, result is much higher than 30%. So, this is known as the base rate fallacy. Noting the Bayes rule is the best cure against it. Oh, yeah, let's get rid of this almighty guy. And thank you very much for coming by, too, Bob. Okay. Base rate fallacy. We're done with this, and then we can move on to the next part. Boonda King. Hello, nice to see you here. And yeah, we're just talking about AI stuff. And before we can talk about AI stuff, we have to talk about probability and odds and all sorts of other stuff like this. Naive Bayes classification. One of the most useful applications of the Bayes rule is the so-called naive Bayes classifier. It seems like a way to get your head around stats. And Sick in the Mind, hello! Thank you very much for subscribing with the Tier 1 on Twitch. Let's give you a fun video redeem. How about some Hack the Planet just for you?
Hack the planet! Hack the planet!
Alright, I very much appreciate the Twitch sub. Thank you very much, Sick in the Mind. Okay, so naive Bayes classification. I think we're talking about statistics. Yeah. I mean, I guess you need to understand this stuff to understand how AI makes their decisions. Heck Psycho, hello, nice to see you here. Yeah. Okay, the Bayes classifier is a machine learning technique that can be used to classify objects, such as text documents, into 2 or more classes. This classifier is trained by analyzing a set of training data for which the correct classes are given. The naive Bayes classifier can be used to determine the probabilities of the classes given a number of different observations. The assumption in the model is that the future variables are conditionally independent given the class. We will not discuss the meaning of conditional independence in this course. For our purposes, it is enough to be able to exploit conditional independence in building the classifier. Real-world application, spam filters. We will use a spam email filter as a running example for illustrating the idea of the naive Bayes classifier. Thus, the class variable indicates whether the message is spam or junk mail, or whether it is a legitimate message, also called ham. So spam is fake and ham is real. The words in the message correspond to the feature variables, so that is the number of feature variables in the model. So that the number of feature variables in the model is determined by the length of the message. Why do we call it naive? Using spam filters as an example, the idea is to think of the words as being produced by choosing one word after the other, so that the choice of word depends only on whether the message is spam or ham. This is a crude simplification of the process because it means that there is no dependency between adjacent words, and the order of the words has no significance. This is in fact why the method is called naive. So because the model is based on the idea that words can be processed independently, we can identify specific words that are indicative of either spam, free or last, or ham, meeting or algorithm. So what do we got here? So we got some email examples. Dear Jane, when can we catch up on the marketing of the pharmacy project? How would next Thursday work for you? Best, Gabrielle. Or the spam one. Last chance. You're so close to free snacks. You get 25% off if you sign up now, and then some link. Despite its naivete, the naive Bayes method tends to work very well in practice. This is a good example of a common saying in statistics. All models are wrong, but some are useful. Which means all models are wrong, but some are useful means. So the aphorism is generally attributed to the statistician George E.P. Box. Bob says, Dear Gabrielle, are you free for a meeting? Are you free for a meeting? So, I mean, that would trigger on a couple of things. So you kind of, I mean, I don't know exactly how this works, but I'm guessing that it counts up the number of ham words versus spam words, and then it tries to calculate whether or not the email is spam or ham. Estimating parameters. To get started, we need to specify the prior odds for spam against ham. For simplicity, assume this is 1-to-1, which means that on average, half of the incoming messages are spam. In reality, the amount of spam is probably much higher. So, based on weight, yeah. So to get our likelihood ratios, we need 2 different probabilities for any word occurring, one in spam messages and another one in ham messages. The word distribution for the 2 classes are best estimated from actual training data that contains some spam messages as well as legitimate messages. The simplest way is to count how many times each word, abacus, acacia, zerg, appears in the data, and divide the number by the total word count. To illustrate the idea, let's assume that we have at our disposal some ham, some spam, and some ham. You can easily obtain such data by saving a batch of your emails into 2 files. Assuming that we have calculated the number of occurrences of the following words, along with all other words, in the 2 classes of messages. So we've got our words over here, and then how often they occur in spam messages versus ham messages. So the word million occurs in 156 spam to 98 ham. So dollars this amount, add click this amount, okay, and conferences doesn't appear in any spam messages. Okay, and then we can now estimate that the probability that a word in a spam message is million, for example. A word in a spam message is million, 156 out of this big number right here, which is roughly the same as 1 in 614. Likewise, we can get the estimate that 98 out of roughly 30,000 words, no, 3 million words. This is 300,000 words. Sorry about that, everybody. Which is about the same as 1 in 3,127 in a ham message are a million. Okay? Both of these probabilities estimates are small, less than 1 in 500. But more importantly, the former is higher than the latter. 1 in 614 is higher than 1 in 3,127. This means that the likelihood ratio, which is the first ratio divided by the second ratio, is more than 1. To be more precise, the ratio is 5.1, rounded to the 1 decimal digit. Okay, recall that if you have any trouble at all with following the math in this section, you should refresh the arithmetic with fractions using the pointers that we gave earlier. See the part about odds in the section odds and probability. 0 means trouble. One problem with estimating the probabilities directly from the counts is that 0 counts leads to 0 estimates. This can be quite harmful for the performance of the classifier. It easily leads to situations where the posterior odds are 0 to 0, 0 out of 0, which is nonsense. The simplest solution is to use a small lower bound for all probability estimates. The value 1 out of 1 million? 1 out of 100,000, for instance, does the job. Okay? Using the above logic, we can determine that the likelihood ratio for all possible words without having to use 0, giving us the following likelihood ratios. Okay, so we get likelihood ratio of spam to likelihood ratio for $1 million ad click in conferences. So the highest one is for the word million. So likelihood of spam, I'm guessing in this case. So ad click is very, very high. Million is very, very high. Conferences is very, very low. Okay, we are now ready to apply this method to classify new messages. Example. Is it spam or ham? Once we have the prior odds and the likelihood ratios calculated, we're ready to apply the Bayes rule, which we already practiced in the medical diagnosis case as our example. Okay, it's too Bob says the likelihoods of words existing at all. These words existing at all in the spam versus ham. So how likely are you going to see these words in spam messages versus ham messages? I'm guessing that the likelihood ratio for spam messages of conferences is very low, but ad click is very high. Okay. The reasoning goes just like we did before. We update the odds of spam by multiplying it by a likelihood ratio. To remind ourselves of the procedure, let's try a message with a single word to begin with. For the prior odds, as agreed above, you should use the odds 1 to 1. Millions gets messaged a lot in both types. Message gets millions a lot in both types. Conferences almost never gets mentioned. Okay. So this is the exercise. 1 word spam filter. Let's start with a message that only has 1 word in it, million. So your task, calculate the posterior odds for spam, given that this word using the table above. Starting with the prior odds 1 to 1. Keep in mind that the odds is not the same as the probability, which we would usually express as a percentage. Give your answer in the form of a single decimal number, using the dot as the decimal separator. Remember that odds can be represented as numbers separated by a colon, or simply as a single decimal number. So a single decimal number, I'm guessing like percentages? You may wish to revisit the discussion on this just before exercise 9 in section 3.1, odds and probability. Okay, so we're trying to figure out if the word million, we need to calculate the posterior odds of million being in a spam message. Okay, so we only have a couple of minutes to do this. We might take a little bit of extra time. Okay, so we need to do is we need to figure out a few different things. So the posterior odds, like mentioned before, it's going to be the likelihood ratio times the prior odds. So we know that the prior odds. Okay, so this is what, one word? Whoa, task manager. One word spam filter. This is the exercise. We need to calculate the posterior odds. And we do that by calculating the likelihood ratio and the prior odds and multiplying them together. The prior odds is defined for us as given as like 1 to 1. What we need to do is we need to figure out the likelihood ratio. So the likelihood ratio is 1 to 1 and 5.1. 5.1. Where was 5.1 mentioned? So likelihood ratio is odds of not spam divided by odds of no spam. So odds of spam divided by odds of not spam to get the likelihood ratio. Okay, it was in the used amount. Okay, so if we go over to million. Okay, so the likelihood ratio, we're given the likelihood ratio. Okay. So the likelihood ratio is 5.1. So we're given the likelihood ratio and the prior odds. So that means that the posterior odds are 5.1 times 1 to 1. And that's going to be equal to 1 to 1. So it's 1 times 5.1. 1 times 5.1. So it's 5.1 to 1. 5.1 to 1. We can divide this. So this is equal to 5.1 out of 5.1 divided by 6.1 to get our percentages. 5.1 divided by 6.1. Okay, so if we go over to our calculator, we calculate 5.1 divided by 6.1, we get 0.83. 0.83. So is this the number they wanted? Okay, so give the answer in the form of a single decimal number x.x, using the dot as the decimal separator. So, I mean, are they looking for 0.8? So it's an 80% chance that it's spam if the contents only have the word million. Let's submit this. Your answer is not correct. The correct answer is 5.1. What was I doing? The correct answer is 5.1. As you may have noticed, the structure of this exercise is identical to the one of the previous exercise about medical diagnoses. we have the class labeled spam or ham and one piece of evidence that we can use to update our prior odds to obtain the posterior odds. We decided above that the prior odds are 1 to 1. The likelihood ratio is obtained by dividing the probability of the word million in spam divided by the probability of the word million in ham. This we already calculated above, and it can be found in the table of likelihood ratios. The value is 5.1. So again, multiply the prior odds by the likelihood ratio to get 1 to 1 times 5 to 0.1 equals 5.1. This is the posterior odds. Again, the posterior odds means that for the messages to include the word million, there are on average 5.1 spam messages for every ham. Or if we use whole numbers, there are 51 spam messages for every 10 ham messages. The probability of the value is 51 divided by this number, or approximately, well, we got this percentage, so let's just say that we got the question correct. Okay. You gave the probability value 83.6, not 0.83. You did that last calculation. I mean, we were working with the same numbers, but I guess I misunderstood the question. Okay, to handle the rest of the words in the message, you can use exactly the same procedure. The posterior odds after one word, which you calculated in the previous exercise, will become the prior odds for the next word, and so on. Okay, so we need to move away from this topic, but yeah. Everybody, if you want to learn the same stuff we're learning, this is the link over here. You were close. Yeah, I guess my reading comprehension skills were not up to the task. Anyways, we'll do an hour of the next topic. So the next topic is going to be PicoCTF. So we're going to be talking about some basics with PicoCTF. So if you are looking for some cybersecurity basics, this is the place for you. Okay, let's get rid of some of these windows we're not using, and let's do some PicoCTF. Okay, so we're going to be covering a number of different challenges today from PicoCTF. Let's get the list. So if you ever wonder where all of our walkthroughs for all of our exercises that we're covering is where they're located on the GitHub over here. Okay, we're doing PicoCTF 2026, and we're going to be doing some general challenges in here. So, I mean, let's go ahead and do this in order. Although these are all kind of related. Well, most of them are kind of related, except for the pseudo make me a sandwich. But we'll do that one last. So we got 1, 2, 3, 4, 5 different exercises we're going to be doing today. Let me go ahead and bring this one up first. This one's called undo. Okay. If you want to do the same challenge we're doing, you can access it from this link over here. So before we get started, we're going to be solving most of these challenges. We're going to be solving all of these challenges on the PicoCTF web shell. So the web shell is a tool that everybody has access to if you've got access to PicoCTF. And if you don't have an account over at PicoCTF, you can make one for free, which means that there's no excuse for you not to do this if you want to do them. It's exactly the same thing as the one you just solved. Okay, so let's see. Bob says, none of my business, but Les Matt's way of explaining this is to draw a single line on a piece of paper, and then shut your eyes and randomly draw dots all over the page. Randomly draw dots all over the page. It's exactly the same thing. Same thing as the thing you just solved. I mean, I understand that you have to use when you're talking about statistics and probabilities, you need to talk about like math formulas. It's fine. It's just that I'm not super good at math. But anyways. Okay, so the first thing you want to do if you want to open up the PicoCTF web shell is to log into the website. So after you've logged into the website, you want to click on this button over here. On the right hand side of the screen, it's labeled web shell. So go ahead and click on that. Oh, okay. I think I began to understand it, Bob. So draw a single line on a piece of paper and then draw dots all over the page. You label one side of the paper with spam and one side of the paper with ham. Okay? So this is the PicoCTF web shell, and it's already kind of full screen, but it's not full screened enough, so we can go over to the top of the web shell header and then click on this button over here, which is labeled Pop Out Web Shell Terminal. So after you do that, then you should be able to get the web shell in full screen, which is the preferred way to work with it, since we have the maximum amount of space. Okay, so this is the link over here that you can go to after you've logged in. I think we can reload this page. Okay, so after that, we've got access to our web shell. We can clear the screen. Clear. Oh, wow. We can't clear the screen. That's weird. Huh. I mean, we can access this stuff. Let me just get rid of this stuff first. Actually, we'll make a directory for this challenge. So this challenge is called undo. I don't think we need it in a directory for this challenge. That's weird. We can't clear the screen. Can you set the term environment variable? So the only environment variable is this. Do we need to... Term environment variable not set. So this is... let me just check what my environment variable is for Kali Linux over here. So environment variable is... So term is xterm 256 color. I wonder if we could clear the screen after we set this. Oh, no. Okay, so it's export, right? So export term equals xterm 256 color. It's set. I think export also works. Okay, so anyways, we can clear the screen, that's good. I'm kind of surprised that this isn't built in. Anyways, let's go ahead and start the challenge. Alright, so this is the undo challenge over here. And thank you, it's Bob, thank you. Okay, so here we go. Alright, so actually before we do this, let's load up the presentation file that I've got for this challenge as well. Okay, now we can start. Alright everybody, this is a guided walkthrough for the Undo Challenge, which is a challenge from the PicoCTF 2026 event in their general skills category. So the description for the challenge says, can you reverse a series of Linux text transformations to recover the original flag? Additional details will be available after launching your challenge instance. So this is one of those challenges where you need to start up a server in order to access the challenge. So we can do that by clicking on the green button, which is labeled Launch Instance over here. So we click on that, and then we wait for a second or two for the thing to start up. So afterwards, you're going to see a instance time remaining counter over here. This lets you know how much time you have to interact with the challenge. So it's set at like 15 minutes. It should be enough for us to do the challenge. So it says start searching for the flag here, netcat foggycliff.picoctf.net, and then a port number. So this is the command we're going to be using to interact with the server where the challenge is. So we can copy this. So highlight the entire command, right click, choose copy, then go back to your web shell. In the web shell, you can paste this command in, and then you can issue the command to see the challenge. So we see here, it says, welcome to the Text Transformations Challenge. Your goal, step by step, recover the original flag. At each step, you'll see the transformed flag and a hint. Enter the correct Linux command to reverse the last transformation. It says here, step 1, current flag. So we've got this really long string of text over here. and it says hint, base64 encoded the string. Enter the Linux command to reverse it. So what are we talking about here? Let's talk about it briefly. So this is PicoCTF 2026 undo. In this challenge, we're asked to reverse some text transformations to get the flag. So the first thing we're doing is we're doing some base64 encoding and decoding. When we connect to the server, we're asked which Linux command will base64 decode a string. So enter the Linux command to reverse it. So this is base64 encoded information here. So what is base64 encoded information? So base64 is a system of encoding that transforms data into a string of characters that includes uppercase and lowercase letters, numbers, and a couple of special characters like plus and slash. So these are the type of characters you would see in a base64 encoded string. So they're your uppercase letters and lowercase letters, your numbers, and a couple of special characters. So what we need to understand here is that with Linux, we can use the base64 command with the -d argument to decode base64 strings back into their original contents. So if we have a string and then we base64 decode it, we'll get back the original contents. So let's demonstrate over here. So if we echo out some message, so say PicoCTF, let's make this a little bit bigger. So if we echo out some message PicoCTF, and then we want to base64 encode it, we would pipe this echo command into base64, and this is the base64 encoded string that results. If we wanted to reverse this process and turn this base64 encoded string back into the original message PicoCTF, we would echo this out, and then we would pipe it into the base64 command again, but with the decode switch, -d over here. So this gets our original message back. So this is the command we want. So we're just going to copy this, and we're going to go back to our web shell, and we're going to paste in that command, base64-d. So after we do that, we get this answer correct. Step 2. So the current flag now looks like this. Okay, and we have a hint over here. It says reversed the text. Enter the Linux command to reverse it. So how do we reverse the text here? So let's talk a little bit more about this. So in the second step, It's 2Bob says, do we get to shout out rev thing base64d? Yeah, certainly. You can comment all you want. Okay, so in this step we're doing string reverse. So the next step in this challenge requires us to reverse a string, that is outputting the string contents in reverse order. So ABC would become CBA, etc., etc. So reversing a string in Linux is easy with the rev command. So the command is just called rev for reverse. So if we echo out something like PicoCTF and then pipe it into rev, then we get the reversed string. So it's going to be PicoCTF, but in reverse. So that's how you see it. And so this is the answer for the next thing, for the next message. So if we go back to the web shell here, so enter the Linux command to reverse this, it's rev. Hit enter, and then we've got step 3. So the current flag looks like this. And the hint here says, replaced underscores with dashes. Replaced underscores with dashes. Enter the Linux command to reverse this. So if we want to replace certain characters with certain other characters, there's a very easy way to do this, and that's going to be with the tr command. So the next step in the challenge is to replace the dashes in the string with underscores. So dashes, get rid of those, replace them with underscores. So the Linux tr command can be used to replace characters in strings. The first argument to the command are the characters to target, and the second argument is the characters to change the target to. So if we've got PicoCTF, and then we run the tr command to replace the string pico, or these characters PICO, with these characters FROG, the resulting string is not going to be PicoCTF, but FrogCTF, because we use the tr command to replace pico with frog. So in this case, it was going to be tr, but replace dashes with underscores. So in this case, it's going to be tr, replace dashes with underscores like this. So tr, and then between some quotes, the dash, replace it with underscore. So we can copy this, and then we can provide this as the answer for the next part over here. Paste this in. Okay, and it says correct. So the current flag is, it looks like this now. So hint, replace curly braces with parentheses. If Bob says, tr equals translate, for what it's worth I humbly offered the listener. Yeah, so tr equals translate. I mean, the tr command can be used to replace characters, it can be used to delete characters. It's a pretty useful command. Okay, so we're going to be doing more tr, but in this case, we're going to be replacing curly braces with parentheses. So the parentheses are here. We need to replace these with curly braces or curly brackets. So in this case, the command looks kind of like replace the parentheses with the curly brackets, like this. So we can copy this command here, and then give this to here, okay, and it says correct. Step 5, the current flag is this. So hint, applied rot13 to letters. Rot13, we'll be talking about what rot13 is in just a second. So what is this other transformation we're talking about? So this is what is called rot13 encoding and decoding, or encryption and decryption. So technically this would be called encryption and decryption because rot13 is a cryptographic cipher. The last step asks us to apply a rot13 transformation to a string. So what is rot13? Rot13 encryption is a common application of the Caesar cipher, which is a classical encryption method where the letters in a string are shifted in number of letters to form a ciphertext. So in this case, for every letter in a message, we would rotate that letter by 13 letters to get the ciphertext message. So the secret message, let's say the secret message has the letter A, we would rotate it by 13 positions to get the letter N. Or if the secret message has the letter I, we rotate it 13 positions to get the letter V over here. So in Linux, we can also use the tr command to perform a rot13 transformation since we are replacing certain letters with others. So in this case, if we apply the rot13 method with tr, we target the capital letters A to Z and then the lowercase letters A to Z, and we replace them with the uppercase letters N to Z and then A to M, and then the lowercase N to Z and A to M as well. So let me go ahead and craft that. So it's going to be, so it's A to Z and then lowercase A to Z, and we replace that with N to Z, and then N to Z. Wait, what does it look like? A to M, and then lowercase N to Z, and A to M, like this. His T-Bomb says, cool fact, rot was used by Julius Caesar in the 1st century BC to protect military instructions. Yeah, that's how it goes. It supposedly was used by Julius Caesar, and that's why it's called the Caesar cipher. So let's go ahead and copy this. And just to make sure this works, let's try echoing out a test message. Okay, so this looks about right. So let's go ahead and copy this tr command here, and then give it to the program. Paste it in. Okay, so it says, congratulations, you recovered the original flag. So the original flag is here. So my flag is going to be different from your flag because the contents on the end over here are going to be different for each user. So definitely copy your own and not copy the one that I have here. So highlight the flag, select copy, and then go back to the challenge here. At the bottom of the challenge, there should be a flag submission field. Click in, paste in the flag, and then click on Submit Flag, and then you're finished. Alright everybody, this was a guided walkthrough for the Undo Challenge, which is part of the PicoCTF 2026 event as part of their General Skills Challenges. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, so it's to Bob. Yeah, thank you very much. Alright, Bruhahaha, hello, love Pico. Udaman in Rot 13, thank you very much, it's to Bob. Alright, let's move on to the next challenge. But Bruhahaha, hello, nice to see you here. What is up? I think I saw you in somebody else's chat. Was it, oh gosh. Whose chat was it? Anyways, I don't really remember. Okay, we'll move on to the next challenge. Let's take a look at what the next challenge is. So the next challenge we're looking at is Pebble? Probably Pebble's chat, yeah. Okay, so the next challenge is Bitemancy 0. So Bitemancy 0, it's basically a challenge where you need to play around with some Python scripts, and we know we love Python over here. Tyler, maybe? Oh yeah, it was Tyler, yeah. I think it was Tyler's live stream. He was talking about like cybersecurity channels on YouTube. Yeah, that was a pretty good stream. Okay, so we'll set up a directory to do this next challenge. Let's talk about this after we start. Okay, so this one's called Bitemancy. Bitemancy 0. Alright everybody, this is a guided walkthrough for the Bitemancy 0 challenge, which is part of the PicoCTF 2026 event as part of their general skills set of challenges. The description says, can you conjure the right bytes? This program's source code can be downloaded here. Additional details will be available after you're launching your challenge instance. So the first thing we're going to do is we're going to launch the challenge instance, which we can do by clicking on the blue button over here, Launch Instance. So that's going to start up the server that hosts the challenge. So the next thing we're going to do is we're going to take a look at the program's source code. You can download it here. So we're going to highlight the here link, and we're going to right click it, select copy link. Then we're going to go over to our web shell. In the web shell, we're going to create a directory to solve this challenge. So we're going to make a directory called Bitemancy 0. And then we're going to enter that directory. Okay, so after we've done that, we're going to copy over the link we copied. We're going to copy over the file from the link we copied. So we're going to type in wget and then space, and then paste in the file address here, the one that we copied. So this is app.py. After we hit enter, we should download the Python file, and what we want to do is we want to take a look at this Python file to figure out how the application works. So we're going to type in nano app.py, and then we're going to take a look at what's going on here. So, so what it does is it sends a little message. It says, send me ASCII decimal 101, 101, and 101, side by side, no space. And then it does a check. So if user input is equal to hex 65, hex 65, hex 65, then open the flag.txt file and read it. Okay? Else, print out, that wasn't it, I got something something. So what we can do is we can actually take a look at how this program works by running the Python command. So run Python. Okay, It's2Bob says, thanks for the stream, enjoy your night. Okay, no problem, It's2Bob. Yeah, thanks for coming by, and we'll see you next time. So Python app.py, and then we get the message. Send me ASCII decimal 101, 101, 101, side by side, no space. So if we don't know what this is, we might type in something like 101, 101, 101, and that says, that wasn't it, I got 101, 101, 101. So what's actually going on here? Let's talk about this. So this is PicoCTF 2026 Bitemancy 0. So in this challenge, they want us to conjure the right bytes. But what does this mean? So it says man ASCII? Yeah, you would man ASCII this. But the first thing you want to do is you want to figure out what exactly they're asking for. So in this challenge, we're given a Python script to inspect. So we just downloaded it and we took a look. And the key part of the script is that if we send specific bytes as user input, the flag.txt file contents will be read to us. So it says ASCII decimal 101, 101, 101, if user input is equal to hex 65, hex 65, hex 65. But what does this mean? So these two numbers, so 101 in decimal or 65 in hexadecimal, refer to ASCII encoding. So for x65, the x refers to hexadecimal notation. So inside of code, if you ever see the letter X preceding a number, this means that the number is going to be interpreted as hexadecimal notation. So base 16 numbers. So decimal numbers or hexadecimal numbers can be encoded into ASCII characters. And ASCII characters are the most common character encoding on the internet. And the character associated with decimal 101 and hexadecimal 65 is the letter E. So if you've got the number 101 or hexadecimal 65, these both are going to equate to the letter E on your keyboard. So it says, so either A or E, depending on which column you use, only one is correct. So 101, 65, 41, A, 145, 101, 65, E. So depending on uppercase or lowercase letters, it's going to be different because these are considered to be different characters. So in this case, decimal number 97 or hexadecimal number 61 is the letter A, and in this case, decimal number 101 or hexadecimal number 65 is associated with the letter E. So we can actually see this if we go over to our terminal over here and we run a Python command. So the Python command, we're going to print out a character. In this case, we're going to print out hexadecimal 65. So if we print hexadecimal 65, oh, does this work? No, we want to put this between some quotes. If we print hexadecimal character 65, we get the letter E. So the letter E is what we're looking for, and they're looking for the letter E 3 times in the code. So they're asking for if user input is hex 65, hex 65, hex 65. So what we can do is we can go back to the challenge. In the challenge, we see that we have to connect to the program with netcat, and they give us a netcat command over here. We'll copy the netcat command, and then we'll go over to the web shell. And in the web shell, we're going to exit from the program here with Control-C. And then we're going to run the netcat command. Paste it in. Send me ASCII decimal 101, 101, 101, side by side, no space. So we figured out that ASCII decimal 101 is actually the letter E. So they're looking for E, E, E. So 3 of these. Send that over, and then we get the flag. So PicoCTF, printable character, something, something. So we can copy the flag, then go back to the challenge, and then we can paste in the flag and submit this to finish the challenge. Alright, everybody, that was a guided walkthrough for the Bitemancy 0 challenge, which is part of the PicoCTF 2026 event as part of their General Skills series of challenges. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Alright, so we're going to do one more in this series. It gets a little bit more complicated than the previous one. The next challenge is going to be called Bitemancy 1. So let's go ahead and bring that up. And let me get the presentation file for that before we get started. Bitemancy 1. Okay, and let's see, where's my web shell? So remember, everybody, if you want to exit from a program that you're currently in, you want to use your Control-C keyboard shortcut to cancel out of the program. That'll cancel out of the command that you're running currently. So let's get out of this directory, and we'll get rid of that directory because we're not using it anymore. Oh. Okay, let's go back to the challenge. Get this started. Alright everybody, this is a guided walkthrough for the Bitemancy 1 challenge from the PicoCTF 2026 event as part of their General Skills series of challenges. It says, can you conjure the right bytes? The program's source code can be downloaded here. Additional details will be available after launching your challenge instance. So in this case, what we want to do is we want to launch the challenge instance by clicking on this button right here, labeled Launch Instance. So that's going to launch the server that hosts the challenge, and then afterwards, we're going to see... the server did not respond. Okay, we'll click on it again. I wonder, the server did not respond. Just a second. Okay, let's go back to Bitemancy 0. And so this is not running. I was, for a minute I thought that it might be preventing me from starting up the instance because I've already got an instance running, but that's not the case. Okay, so launching challenge instance, and then Tech Unknown says, are you recording all the web app basics? Because I can't find the latest ones on your YouTube. The web app basics, I can't find the latest ones on your YouTube. The web app basics. Tech Unknown, hello, nice to see you here. Let me see if I can find those for you. So web app basics, I'm not too sure if I've got that in a playlist, but I'm pretty sure that we've got a playlist for web app stuff in general. Let me see if I can find that. Web app hacking challenges. Okay, so let's try looking here. Okay, let's go back. All right, so we've got our instance running now, and we also see a link. So the program's source code can be downloaded here. What we're going to do is we're just going to copy the link for the source code. So right-click on the link, select copy link, then go back to the web shell. In the web shell, what we want to do is we want to create a directory for this challenge. So make directory Bitemancy1, and then enter that directory. Okay, and after we do that, what we want to do is we want to wget to download the Python file. So wget space, right-click, select paste, and that's going to paste in the file address that you just copied. Hit enter, and that's going to download the file. So it's called app.py. What we want to do is we want to inspect this file with the nano text editor. So nano space and then app.py. That's going to open up the nano text editor, which we can use to take a look at the code for this particular Python file. So it says here, print send me ASCII decimal 101 1751 times, side by side, no space. So we're dealing with the same ASCII character as we were in the previous challenge. And it also says if user input is equal to hex 65 times 1751, then open flag.txt and then read the flag. So what are we dealing with here? So in this challenge, like the previous one in the series, they want us to conjure the right bytes. But what does this mean? So we're talking about ASCII bytes again in this challenge, and we're given a Python script to inspect. If we take a look at the Python script, we see that the key part of the script is that if we send specific bytes as user input, the flag.txt file contents will be read to us. So in this case, it's hex 65 times 1751. So like the previous challenge, we need to send a certain byte, which is the same byte as the previous challenge, only repeated 1751 times. So how do we deal with this? So hexadecimal numbers can be encoded into ASCII characters, and the character associated with hexadecimal 65 is the letter E. So it's the same character we did last time, only we need to send it many, many times. So to send the exact number of characters, we can use a Python command. So in this case, we're going to be using Python to print out a bunch of characters, and then afterwards, we're going to pipe this into the program that we're supposed to access. So I'll show you how to do that. So if we go into our web shell, and then we get out of the text editor, Control X to exit from the text editor, we're going to run a Python command, python-c, and we're going to do print. We can do either hex 65, so 0x65, or we could also print E. It doesn't matter which, but just to prove that this is exactly what we're looking for. So hex 65 times, what was like 1751, was it? What was the number? 1751, okay. 1751. Okay, and this is the command we're going to be using to print out all of these characters here. So if we run the command, we just get a bunch of E's. So that this is what the program's looking for. It's just a bunch of E's. What we can do next is we can pipe this into the program that we want to access. The program we want to access is back here. It says connect to the program with netcat. So we're just going to copy this command, and then we're going to go to our web shell. We're going to do the same thing we did before, python-c print hex 65, times 1751. And then we're going to pipe that. So give the pipe character here, space, and then paste in the netcat command over here. So what this is going to do is it's going to run netcat and connect to the program, and it's going to pipe in the results of the Python command over here, which prints out all of the E's. So when we run the command, we see that the program here, send me decimal 101 1051 times, side by side, no space, and we just did that with the Python command over here. What we get in return is the flag. So PicoCTF, how many E's? And what you want to do is you want to copy the flag. Then you want to go over to the challenge description. In the challenge description, scroll down. And then in the flag submission field here, click into it, select paste, click on submit flag, and then you're finished. All right, everybody, this was a guided walkthrough for the Bitemancy 1 challenge, which was part of the PicoCTF 2026 event in their general skills series of challenges. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. We're not leaving, it's just that I have to say that for all my YouTube videos. All right, so let's move on to the next challenge. So before we start the next challenge, let me go ahead and put on some new music. How about some music from XCOM 2, which is super dramatic for no reason at all. All right, so the next challenge we're going to be doing is, which one? It's going to be the Multicode challenge. All right. Instructions unclear, licking all the buttons now. Lick the lick and subscribe button, yeah. Okay, this is the Multicode challenge, and well, I mean this is on theme for all the other stuff we're dealing. We're dealing with transformations, we're dealing with encoding stuff. There's going to be more encoding in this challenge, and let's go ahead and get that started. I think I'm going to restart my web shell because why is the web shell so janky now? Term, okay, we have to export. Term equals, what is it called again? Xterm 256 color. Blame Canada Internet? I mean, the Canadian Internet isn't making the web shell wonky. That's neither here nor there. Let's remove our Bitemancy 1. Shia, do you ever play Stellaris? You ever play Stellaris? I don't think so. The name of the game sounds kind of familiar though. Okay, let's go ahead and start the challenge. This one is Multicode? Multicode, okay. Banger soundtrack in Stellaris. Oh, okay. I should probably look that up sometime, because I'm always on the lookout for new cool sci-fi soundtracks. All right, everybody, this is a guided walkthrough for the Multicode challenge from PicoCTF 2026 as part of their general skills series of challenges. The description on the challenge says, we intercepted a suspiciously encoded message, but it's clearly hiding a flag. No encryption, just multiple layers of obfuscation. Can you peel back the layers and reveal the truth? Okay, and then we get a link to download the message. So the first thing we want to do is we want to copy over the message file to our web shell. So we can highlight the message link over here, right click, and then copy, and then select copy link. After we do that, we're going to go over to our web shell, and in the web shell, we're going to create a directory to work inside of. So we're going to make a directory called Multicode. and then we're going to enter that directory. Okay, so we're in the Multicode directory now. Now we can download the message. So wget space, right click, paste in the file address, and then hit enter to download the message. Okay, try not to, because he always answers and I want to ruin the video. No worries, no worries, I can always clip this stuff out. Okay, so we see message.txt is in the directory now, and then we can read it. So what we have here is we've got a very long string with some interesting looking content. So we've got uppercase letters, lowercase letters, and we also have an equal sign at the end over here. So what we're dealing with in this first part of the challenge is we're dealing with something called base64 encoding. So it says, I got Shapes 2 and Little Big Adventure soundtracks on my current focus playlist. Yeah, you know what I should do? I should probably start writing down some of these suggestions. So we got Stellaris, and then we got Shapes 2. Okay, I'll just keep this in my browser window. I can look it up later. So let's talk about this. So this is PicoCTF 2026 Multicode. In this challenge, we're asked to decode multiple layers of encoding to read the flag. So the first thing we encounter here is something called base64 encoding. So the first layer of encoding in this message is base64 encoding. This encoding system takes data and encodes it into a text string with uppercase and lowercase letters, numbers, and a couple of special characters, the plus sign and the slash. So if you see a text string with these types of characters over here, so uppercase letters, lowercase, numbers, and the plus or slash, this might be a base64 encoded string you're looking at. So we can use the Linux base64 command to decode the string. So if we take a message, this is an unencoded text here, and then we base64 encode it, we would get this string right here. If we wanted to decode the string, we would take this, we would echo it out, and then we would apply base64-D, which is decode, to get back your original message. So what we can do is we can use the same cat command here, but we can pipe it into the base64 decode command. So cat message.txt pipe base64-D. So what we get in return is a string of numbers and letters. So we see a bunch of numbers, but we also see a couple of letters in here. So the letter F, the letter F, and so we know that we're not dealing with decimal numbers. What we're dealing with here are hexadecimal numbers. So the next layer we're dealing with is hexadecimal ASCII encoding. So this resulting output is a string of numbers and letters, which appears to be hexadecimal digits. This points to hexadecimal ASCII encoding. So ASCII encoding is an encoding system where strings of numbers are converted to ASCII characters and vice versa. So for example, if we were to print out ABC, and then we were to use a program to decode these from ASCII into numbers, or sorry, into hexadecimal digits with the XXD program over here, we would get these hexadecimal digits over here. So 41, 42, 43. So A is 41, B is 42, and C is 43. If we wanted to encode these into ASCII, we would echo out these numbers, and then we would use the XXD program again to encode them into ASCII, and we would get back the letters ABC. So using Linux, we can convert hexadecimal digits to ASCII and vice versa with the XXD program. So let's demonstrate this. So if we go back to our web shell, and then we get our original command here, let me copy this. Okay, and then we do the previous two commands, but we also pipe it into a new command called xxd, so -r to reverse the output, and -p to get it in a printable format. So if we do this command here, it converts the hexadecimal numbers into ASCII characters. So we see here that this is the result. So this looks almost like a regular ASCII string, except we see some more encoded characters here. So this is an encoded character, and this is also an encoded character. What we're dealing with is something a little bit different, and let's talk about what that is. So this next step is something called URL encoding. So now the output string looks like it's been ROT13 encrypted. We'll talk about that in just a second, but there's also some URL encoded characters in the string. So you see here we got %7b and we've got %7d. We need to decode these before we proceed. So what is this URL encoding we're talking about in this step? URL encoding is applied to web addresses and transforms characters that are usually not allowed in URLs, such as special characters like $, brackets, single character, single quote, double quote, stuff like this. The way we encode these is that we encode them into a % symbol followed by 2 hexadecimal digits. So in this case, the space character here, so my space file.txt, gets converted into my %20 file.txt. So this space has been encoded into %20. So the 2 hexadecimal digits used with the % sign in URL encoding map directly to the hexadecimal digits for ASCII encoding. So if we do if we do %41 and we encode this into, well, if we decode this, it becomes the letter A, and if we decode %20, it becomes the space character, and these are associated with the ASCII encoding. So if we go over to like a website like urlencoder.org, and we wanted to, we value your privacy. That's great. Agree? Sure. Take my cookies. All right, so if we go here and then we encode ABC space DEF and then click on encode. Let's see, where's the result? Oh, it didn't do it. Hold on. Encoder to URL format. So ABC space DEF and then encode. What we get is ABC because these are allowed by URLs, so regular letters are, but the space has been encoded into the %20. So if we also go from encode to decode, and then we decode %41 and then %20 and then %41. So what should show up is the letter A and then a space and then the letter A again. Okay, so we decode this, then we get A space A. Okay, so all that to say is that we can decode from URL encoding to get some special characters. Where are we here? So on Linux we can use Python, so we can use the Python program to URL decode special characters back into the original forms. So we'd use Python and then import some modules, and then we would run the module functions in order to decode the message. Let me get the particular Python command right now. Okay, so if anybody's interested, this is the command you would use. Okay, so let's go back to the web shell. So the only thing we're doing in this part of the challenge is decoding the URL encoding. So we're just going to copy this, clear the screen, and then we're going to do the previous command. We're going to pipe it into the Python command. So I'm going to grab that, paste it in. So what we're going to see is that this is going to give back our curly braces. So this is the left curly brace here and the right curly brace here. That's been decoded. Anyways, we got ads running on Twitch right now. When ads run on Twitch, we take a little break and have some water. But in the meantime, we can hang out with the birds. Let's see. How about this happy bird? Okay, we'll be back in about 60 seconds, but enjoy the birds and enjoy the music. Okay, let's put the birds away and let's get back to the hacking. Alright, so we see here, we still have an encrypted string over here, and let's talk about the last transformation we need to do to finish this challenge. So the last step we're doing here is called flag format inference. So, okay, we think that this is the PicoCTF flag. So the resulting output looks like a CTF flag that has been encrypted with the substitution cipher. So how do we know that this is a CTF flag that has been encrypted with the substitution cipher? The format. So all PicoCTF flags start with the word PicoCTF followed by some contents between a pair of curly braces, which is very similar to what we see here. Known plain text. I guess that's what you could call it. Sick in the mind, thank you. So the most common substitution cipher used in cybersecurity challenges is ROT13, the simplest application of the Caesar cipher. In ROT13 encryption, each letter of the ciphertext, that is the secret message, is rotated 13 positions in the alphabet to form the plain text, otherwise known as the original message. So for example, the letters ABC would become the letters NOP. So A becomes N, B becomes O, and C becomes P, and vice versa. So if we transform NOP, N becomes A, O becomes B, and P becomes C. So this is how we do encryption and decryption using ROT13. So in Linux, we can apply the TR command to apply the ROT13 encryption and decryption operation and get the fully decoded flag. So this is what we're going to do. So this is, let's explain what the command does first. So the command is called TR. We have to specify the characters we want to transform. In this case, it's A to Z, and then lowercase a to Z. We wanted to convert it over to N to Z, and then M to, and then A to M, along with the lowercase. Oh, I've done this incorrectly. Okay, so with the lowercase A to N to Z, and then A to M, like this. Okay, A to Z, treat the second hyphen as literal. No, yeah, gotta catch our typos when we can. So let's do a little experiment here. So we're gonna echo out some message and apply the ROT13. This is the plain text. Okay, and then we get this message over here. So this is what we want to do to our ciphertext message to convert this over to the plain text. So we're going to do it like this. We're going to go back to the web shell. We're going to grab the previous command. Then we're going to pipe it into the tr command. So let me grab that. And then paste this in. Okay, so how many transformations are we doing here? So we're doing base 64 decode into hexadecimal to ASCII, into URL decode, into ROT13 decode. So after we do all of that, we get this flag over here, PicoCTF nested encoding something something. So we're going to copy the flag and then go back to the challenge description, and we're going to paste in the flag. So before we finish this challenge, let me show you how we can do this in another fashion. So we can use our favorite program ever. It's called cyberchef.io. And in cyberchef.io, we can actually do all the transformations from our little recipe bar over here. So the first thing we're going to do is we're going to just get the original message. So this over here, copy the string, then go over to CyberChef. In CyberChef, paste this into the input field, into the input window here. So what we want to do is, first we want to apply base 64 decode, and we can search for all the operations over on the left-hand side here. So type in base 64, and we're going to be decoding from base 64. So here, drag from base 64 into the recipe bar, and then we see in the output, we've got the numbers here. So remember that the next operation is hexadecimal to ASCII. So in operations, we'll look up from hex, because we're doing from hexadecimal to ASCII. So drag from hex into the recipe bar, but below base 64. So here we see, what do we see? We see this new output over here. And remember that the third transformation is doing the URL encoding, or the URL decoding. So we can go back here, we can type in the operations window URL decode. So drag that into the bottommost spot here, and that gets back our curly braces. So the last thing we want to do is we want to do our ROT13 transformation. So ROT13 is here. Drag it in onto the bottom in the recipe, and then we get our final flag, PicoCTF nested encoding. So that was two different methods we could do to solve the challenge. We'll go back to the challenge window here, and we're going to submit the flag. Click on Submit Flag, and then you're finished. Alright everybody, that was a guided walkthrough for the Multicode challenge, which is part of the PicoCTF 2026 event as part of their General Skills series of challenges. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons in the video and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, we've got one more challenge we'll do before we wrap up for the day, because I wanted to do 5 challenges today. The last challenge we're doing today is called Pseudo Make Me a Sandwich. SysOS says, you might want to check this out later. Copy.fail. Copy.fail. Okay, let me check this out. I'll put it in my browser for later. Okay, so Pseudo Make Me a Sandwich. Alright, let's get started. So we're going to be talking about a few different Linux concepts here in this challenge. Hey everybody, this is a guided walkthrough for the Pseudo Make Me a Sandwich challenge from the PicoCTF 2026 event as part of their General Skills series of challenges. The description of the challenge says, "Can you read the flag? I think you can." So additional details will be available after you're launching your challenge instance. So the first thing we want to do is we want to launch the instance. So there's a blue button over here. We can click on it. And then after a few seconds, the challenge instance has been started up. It says, can you read the flag? I think you can. They also give an SSH command for us to use to log into the server. So we need to use this command with this password here to log in and access the challenge. So what you want to do, sandwich makes me think of piping it with something. Yeah, I mean, I'm not, that's maybe not for this challenge. But anyways, what you want to do is you want to grab the SSH command. SSH is a program that lets you log into a remote server. Copy the command, go over to the web shell. In the web shell, paste in the command, and then hit enter. So they're going to say, this key is not known by any other names. Are you sure you want to continue connecting? So this is pretty standard for SSH because we're connecting to a server we haven't before. We want to answer the question with yes. So type in YES, hit enter, then they're going to ask for the password. So the password is going to be different for each user, but you can copy it over here. So using password, this one. So copy the password, then go back to the web shell, right click, paste in the password, and then hit enter. When you paste in the password, you're not going to see anything. This is completely normal for Linux systems. Just paste in and hit enter. Okay, and then we're logged in. So CTF player at challenge. So if you ask who am I, it should say that you're the CTF player user over here. So what's going on this challenge? Let's talk about it. So this is the Pseudo make me a sandwich. In this challenge, we're asked to read the flag somehow. So what we're doing here is we're doing some pseudo enumeration first. When we arrive in the server, we check our current directory and we see that the flag file is here, but we can't read it since we don't have read permissions on the file. So if we go back to our web shell and we do ls to see what's in the directory here, we see flag.txt. If we try to read the flag with the cat command, it says permission denied. So the reason why is because we're the CTF player user, and the flag.txt file is owned by the root user, and we don't have read permissions with this. So we need to figure out some other way to access the file. So this is where Pseudo comes into play. So we can check the Pseudo permissions for our user with sudo-l. So it says here that the user CTF player may run the following commands on challenge. So challenge is the name of the server. As all, which means any user we want, default root. With no password, we can use the bin emacs command. So bin emacs, what is this? We'll talk about it in just a second. So if we check our sudo permissions with the sudo-l command, we can see that we can run the sudo command with the emacs command. So sudo emacs, what does this mean? No pipe sandwich. No, not in this case. So we're talking about the sudo command. Maybe you don't know about it, but this is a very powerful command in Linux. The sudo command is used to run a command in the context of another user, usually the root user, that is the super user. So usually when you run sudo, you're running it as the highest level user on the system. So sudo lets you run commands as the root user for one command at a time. And in this case, we can run it with the Emacs text editor. So the program that we can run sudo with is a text editor called Emacs. So Emacs is a text editor program, so we can read the flag.txt file that is owned by root if we run it with sudo. So sudo, run it as the root user, and then open up the flag.txt file, which contains the flag. So let's go ahead and do that. So back at our web shell, we run sudo emacs space flag.txt. So we're running as the root user the Emacs text editor, and we're editing the flag.txt file. So when we run this, we can see the flag because we're running the Emacs text editor as the root user. So this is the flag over here. We can copy it and then go over to the PicoCTF challenge description. At the bottom of the challenge description, we can paste in the flag. So right-click paste, and then we can submit this flag. So before we submit this, I'm just going to teach you one more thing. Exiting the Emacs program. So exiting the Emacs program is a little bit more complicated than you might think. So it's keyboard shortcut Control X, and then keyboard shortcut Control C to exit the program. So it's Control X, and then Control C. So just so you know. Okay, so let's go back to the challenge description and we'll submit the flag to finish the challenge. All right. Everybody, that was a guided walkthrough for the Pseudo make me a sandwich command. Sorry, not command. The Pseudo make me a sandwich challenge from PicoCTF 2026 as part of their General Skills series of challenges. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, so this was the last challenge for the day. We're going to move on to another subject. So the next subject we're going to be doing is HackerFrogs AfterSchool, which is a program that I created to teach people about basic cybersecurity skills, in this case, about web app security stuff. So where is my sandwich now? Well, I mean, you're going to have to make the sandwich yourself, because I can't send it over the internet. But anyways, let's get rid of our web shell. We're not using PicoCTF anymore. Okay, so if you're looking for our notes for this particular exercise over here, I think I've got it. Yeah, over here. So this is session 8 as part of our web app security course. And let's start. So this is HackerFrogs AfterSchool Web App Session 8, the Burp Suite overview. So to do this particular workshop, you're going to need to have an account over at tryhackme.com. And we're going to be accessing this room over here on TryHackMe. It's called the DVWA, or the Darn Vulnerable Web Application. But before we do that, let's talk about what we learned last time. So what did we learn in the previous workshop? This is the 8th Intro to Web App Hacking workshop. In the previous workshop, we learned about the following web app hacking concepts. We learned about SQL injection last time, and we learned about blind SQL injection, the Boolean-based kind. So this is true or false, trying to figure out whether the things that we send to the database are true or not. So Boolean-based SQL injection is a type of blind SQL injection where the only input that is returned after an SQL statement is whether the query returned true or false. So if you're interested in learning what we learned last time, you might want to go to the previous session of this of the HackerFrogs live stream. So this would be the one from last week on Friday. We also learned about time-based blind SQL injection. These rely on injecting a delayed response into database queries to enumerate information about the database contents. So this is, yeah, this was a pretty involved process. Go back to the Friday live stream if you want to learn more about that. So today, what we're going to do is we're going to talk about a very popular tool in the web app security space, which is called Burp Suite. It's an industrial standard app used for web app security testing. If you've never done web app security testing before, you might open up Burp Suite and you might be overwhelmed at all the options in the program. We're going to be going over some basics of this program. So we're going to be learning more with TryHackMe, and we're going to be using this TryHackMe room over here. It's the DVWA room, and like I said, this is the link over here. What you want to do is you want to join the room if you haven't joined it before. Let me show you what it looks like if you haven't joined. So let's see. Options. reset progress, and then leave room. Just a second. Okay, and then we'll go back to the room. So if you haven't joined the room before, you should see a button down here. It's green. It's labeled Join Room. Click on that, and then after you've joined the room, what you want to do is you want to start the machine. So it says DVWA is an awesome virtual machine commonly utilized in training and testing of new tools. There's a green button labeled Start Machine over here. Click on that to start up the virtual machine with the DVWA app. The other thing we want to do is we want to use the attack box to interact with the DVWA machine. So at the top of the web page, underneath the icon over here, you should see a button labeled Start Attack Box. So click on that, and that's going to start up the virtual machine we're going to be using to interact with the DVWA box. So that's going to take a couple of minutes to start up. And while that's loading up, what we're going to do is we're going to talk a little bit about the Burp Suite application we're going to be testing today. So introduction. Burp Suite is the web app testing tool of choice for cybersecurity professionals who test web apps. It can intercept the traffic from web apps and do all sorts of stuff with that data. Burp Suite captures and enables the modification of web traffic between the browser and the server, and includes the following 5 tools for web app testing. So the first tool we're going to be talking about is the Burp Suite proxy. The Burp proxy server is what enables web traffic to be captured and recorded. It sits between the browser and the server, enabling traffic capture. So let's see what our progress is at over here. So we got 56%. Let's continue. So the second tool is called the Burp Spider, and the Burp Spider is a web app indexing robot which maps out different endpoints inside of a target web app. So if we're talking about similar tools to this one over here, we could talk about Derb, GoBuster, and FerrixBuster. So it's basically ways we can map out the contents of websites. The third tool we're going to be talking about is the Burp Intruder. So the Burp Intruder is a tool that can be used for different web brute forcing attacks with modular payloads and word lists. So tools that are similar to the Burp Intruder include stuff like Hydra, WFuzz, FFUF, etc., etc. The fourth tool we're going to be talking about is the Burp Suite Scanner. So the Burp Suite Scanner is an automated web app vulnerability scanner which tests all endpoints found in a web app for known vulnerabilities. Similar tools to the Burp Suite Scanner are Nikto, OpenVAS, and Zap. And the last tool we're going to be talking about today is the Burp Suite Repeater. So the Burp Suite Repeater is a tool that allows for manual web request manipulation and testing. It lets you replay web requests. So similar tools to the Burp Suite Repeater include tools such as Zap, Postman, and Charles Proxy. So the first thing we're going to be talking about is installation of Burp Suite. While learning Burp Suite, it's recommended to access via virtual machine or VM. So you can use platforms such as TryHackMe or the AttackBox VM or the Kali Linux VM, and you don't need to install it if you access it via virtual machines like this because it's already been installed. Even so, manual installation and download for Burp Suite is available for all major operating systems from the Portswigger company website. So I think if we go over to portswigger.net, which is the home of Burp Suite, there should be a section for downloading Burp Suite. We go to Products, and then we click on Burp Suite Community Edition, which is the free version. And there's a link that you can use to download the program over here. So let me just get you that link in case you want to download it to your own machine. But we see here that we our attack box is finished loading. So this is what we want. So from here on the Track Me page, we're going to click into the terminal on the attack box and hit enter to close this dialog box. And then, because we want to have as much space as possible, we're going to go over to the center of the screen, which is the border between the web page and the attack box, go down to the bottom of the screen, and then there's a button labeled View in Full Screen. This is where we can put the attack box in its own browser tab. So go to the center, go down to the bottom, and then click on this button that's labeled View in Full Screen. It looks like two arrows pointing away from each other. So after you click on that, you're going to see the attack box desktop in full screen view. This is what we want. So after we've done that, what we want to do is we want to start up Burp Suite, because, well, we're here to test out Burp Suite. If you go over to the right hand side of the screen, there's the icon for Burp Suite Community Edition, which is the free version of Burp Suite. Go ahead and click on that. So this is going to load up Burp Suite. It's going to take a few seconds to load. And then afterwards, we're going to have to do a bunch of configuration settings. But in the meantime, maybe we can talk about a thing or two about Burp Suite while this thing loads. Okay, installation, the dashboard. So the dashboard is, for Burp Suite, is subdivided into 4 different sections. When we start up Burp Suite, we should see a screen that looks kind of like this. And we'll cover each one of these windows one at a time. So the first window is the Tasks window, which keeps track of visit web pages in Community Edition. But in Pro Edition, it records scans and other tasks. So one thing we're going to learn about the Community Edition is that there's a lot of stuff that we're not going to be able to access because this is the free version of the program. But it's fine because there's a lot of good stuff that we can still access in Burp Suite, even though we're using the free version. So the first one is the dashboard here. The second thing is the event log window, which shows actions taken by the program for later analysis. So the event log is also something that you're not really going to pay attention to if you're using the Community Edition, because the event log doesn't really get filled up in the Community Edition. So the other thing that we see in the dashboard is the issue activity window, which is also not relevant in the Community Edition, but in the Pro Edition, it displays the vulnerabilities identified in the project scope. So in the Pro version, we can see a bunch of stuff that has been identified by the scanner, and it highlights different types of web app vulnerabilities. So the last thing on the dashboard here is the advisory window, which provides a detailed information about stuff that we identified as vulnerabilities. Once again, this is only something that is supported by the Pro version of the program. So let's go back to our attack box, and we see that Burp Suite is finished loading up. So on the Burp Suite Community Edition startup screen, we want to click on Next, and then we want to click on Start Burp. So these are both down at the bottom right-hand side of the window. And so the Burp Suite Community Edition window is going to start up, and then we can get access to all the stuff in Burp Suite. Okay, and then we can see the dashboard like what we saw in the screenshot. So the dashboard has changed a little bit from when I first made the presentation files. Most of the time, with the free version of Burp Suite, we really don't need to pay too much attention to the dashboard at the top. But there's some other tools that you can access from the top tab over here that we're going to be using in today's lesson. So the tabs over here are actually how you access the different tools inside of Burp Suite. So there's the dashboard, there's the proxy tool, the intruder tool, the repeater tool, the collaborator tool, the sequencer tool, etc., etc. What we want to do first is we want to go over to the proxy tab. The proxy is the most important tool in Burp Suite because it's the proxy tool that records all the traffic between the web application and Burp Suite over here. So what we want to do is we want to go over to the proxy tab, and then we want to click on intercept off. This is the most devilish button inside of Burp Suite. If the intercept is set to on in the proxy tab, you won't be able to make any requests with Burp Suite unless you manually go and accept or drop each one of the requests. So make sure that intercept is switched to off. Okay, so after you switch it off, you know, one thing that we're going to do is we're going to go into the settings, and we're going to change it so that Burp Suite is in dark mode, because we're not hackers unless we're using dark mode. So in appearance, so just go into the settings. Let me show you how. So on the right hand side of the screen here, in the upper right corner, there's the settings button. So click on that. The nice thing about the settings interface is that you can type in whatever keywords you want into the search bar here. And in our case, we want to access dark mode. So type in the word dark, and then under appearance, we can switch the theme over to dark. Click on that, and then we're hackers now because it's dark mode. Okay. So the other thing under appearance is we can change the size of the font because, well, the size of the font in the Burp Suite tool, it can be a bit small. So we're going to change from size 11 font over to size 16. And that's going to change the font of all of the text that appears in the tool. So we're going to click back into dark. Well, click back into the search window here. We're going to look for font, and there are two places where font appears. So in the display window here, but also in the message editor. So the HTTP message display, we're also going to change the font here from 11 point to 16 point. So click on change font, and then we're going to change from 11 point to 16. So of course you can change it to whatever size font you're most comfortable with. Okay, so after we've done all that, we can click off of the settings window here, and then we can continue. Okay, let's go back to the presentation. So navigation. Navigating inside of Burp Suite mostly comes down to selecting the desired tab on the navigation bar. So we got the target tab, the proxy tab, the intruder tab, etc., etc. So you can find these at the top row of the tool interface. So just over here, so dashboard, target, proxy, intruder. You've got an orange line underneath the tool that you're currently looking at. So you're gonna have to get used to this. So if you click on a tab, say the proxy tab, there might be sub-tabs here as well. So the sub-tabs you can find over here, so intercept, HTTP history, WebSockets history, etc., etc. If the tabs are, if there's not enough room for all the tabs on one row, they'll spill over onto a second row over here, just to let you know. So within a specific tab, you can navigate to sub-tabs below the main menu bar. So proxy, intercept, or then, you know, repeater, and then something else, some other sub-tab. So for example, in the proxy tab, there are the intercept, HTTP history, and WebSockets history sub-tabs. And then we got options. So this section is actually about the Burp Suite settings page. Settings can be accessed from the settings button on the top right corner of the UI. So in the top right corner, you'll see the gear icon along with the settings text, and that's going to bring you to your settings menu. So once the settings page is opened, you can access the user global settings or project settings from their respective tabs on the top left of the UI. So this is where we can set up our different... To Fatcho, hey, haven't seen you in a while. but welcome into the stream. What is that the emote? It's Tehe Pello. Thank you very much for coming on by. So we're going over once more that the Burp Suite proxy, so this is a very important tool. This allows web traffic to be recorded, reviewed, and replayed. One thing to take note of is the intercept is on button. So under proxy intercept, the button here that I talked about before, intercept is on. We want to make sure that intercept is never on, except for a couple of very special circumstances. When intercept is on, each web request has to be manually allowed or dropped before the next one can be sent. In most cases, we do not want this, so we should ensure that intercept is on. This button is toggled off. Okay, we also have the sitemap and issue definitions window over here. So target sitemap. So the Burp target tab allows us to define which IP addresses and or URLs are considered in scope for web traffic proxy and capture. So if you don't set up a scope for the traffic that you want to record, it'll record every web request no matter what the origin is. We also have the Burp Suite browser, which is another very important tool for using Burp Suite. Using the Burp Suite browser to proxy web traffic is a more convenient option than using the regular web browser proxies. And Peanut Gamer, hello, nice to see you here. What is up? Welcome to the stream. We're just talking about how to use Burp Suite over here with our TryHackMe page or TryHackMe module. So okay, so how do we access the Burp Suite browser? So to access the Burp Suite browser, we need to click on. Actually, there's one more thing we need to do before we use the Burp Suite browser. We need to go back into the settings. So in the settings, so upper right corner, click on settings, and then click on, and then search for browser. So you should see Burp's browser over here. So this is the browser settings. And what we need to do for TryHackMe's Burp Suite in particular is scroll down to the browser running section. Peanut Gamer says, nothing much, I just reinstalled Burp Suite to try and get into some bug bounty hunting. I need to learn Burp Suite better. Yeah, I mean, Burp Suite is the tool that you use for web app security stuff. So everybody has to learn how to interact with this thing. It's a pretty complicated tool, but when you're dealing with complicated tools, you just need to learn how to do the stuff you want to do. You don't need to learn you don't need to learn everything about Burp Suite, just the stuff that you need to do to get your job done. So under browser running over here, there's a checkbox. The checkbox is labeled allow Burp's browser to run without a sandbox. If we don't click on this, we won't be able to use the Burp Suite browser with the TryHackMe attack box. So go ahead and click on that. Second of Mind says I use it daily. I used to use Burp Suite daily, but I don't do as much web stuff as I used to. Peanut Gamer says I need to go through their Burp Suite University to get the basics down. Burp Suite University, could you give me a link for that? Because that sounds pretty nice. Maybe attempt an easy bug bounty. There's a Burp Suite University? Yeah, that's new to me. Anyways, so make sure that allow Burp's browser to run without a sandbox is selected, and then we can get out of our settings again. So after all this, we can go over to the proxy intercept tab, so proxy intercept, and then afterwards we can click on this button right here, which is labeled open browser. This is going to open up the Burp Suite browser. Okay, I meant the Portswigger learning site. Oh, the web security. Oh, okay. That's yeah, Burp Suite. That's the Burp Suite Labs page. So after you click on open browser, it'll take a little bit of time, but then a new browser tab, well, a new web browser will open up. So you can see that the landing page for this particular web browser is Portswigger Chromium. Portswigger Chromium. So it's called this because the Portswigger browser, or the Burp Suite browser, is a Chromium browser, which is a type of Chrome browser. Okay, and all the stuff that is recorded by the Burp Suite browser is also going to be sent over to the Burp Suite proxy. So what we want to do, well, we'll talk about this in just a second. So it can be accessed using the proxy tab, then the intercept subtab, and then the open browser button. So proxy, intercept, and then click on open browser. So in the attack box, you're going to have to go into the settings, Burp's browser, browser running, and then allow Burp's browser to run without a sandbox. You have to check this box to run the Burp Suite browser if you're running it on the attack box from TryHackMe. Okay, so in most cases, we want to set a scope for our testing and exclude all traffic that is outside the URL or IP address of the scope. So what we can do is we can go back. Well, the first thing we're going to do is we're going to get the IP address for the machine we want to access. So we can go back to the TryHackMe page over here, and we can close out the split view. So on the web page, go down to the bottom and click on the minus button over here, which is labeled Exit Split View. So after we do that, we're going to get the IP address of the DVWA machine, which is this IP address right here. So click on the clipboard to copy it. Then we're going to go over to the attack box. In the attack box, well, you know what we can do? We can paste in. Oh no, we can't paste in. We need to put this IP address into our attack box. We can do that from over here on the left-hand side, and then this button over here, which opens up the control bar. So the control bar is going to have your clipboard for the virtual machine for the attack box. So in the clipboard, paste in the IP address we copied earlier, and then close the clipboard with this button over here. After we do that, in the Burp Suite browser, we're going to paste in the IP address and then hit enter. Okay, so this is the landing page for the DVWA app that we're going to be accessing. So one interesting thing we can do from here is we can actually locate our request to the DVWA app from the Burp Suite proxy tab. So we can minimize this window, then we can go over to Burp Suite proxy, and then in the proxy we can go over to the HTTP history tab. So the proxy HTTP history tab it's going to be a very common thing that you see when you're working with Burp Suite, and in the tab you're going to see all the web requests that you made with the Burp Suite browser. So for example, we got the landing page over here, and we got our login.php page over here. So if we click on this, the landing page here, we're going to see all of the request and response information for the web request. So in here is the request that we sent, and then the response information that we received from the web application in here. Okay, so another thing we can do is we can actually add this IP address to our scope. We can right-click on the request, and then we can select Add to Scope. So right-click on the request, click on Add to Scope. You have added an item to the target scope. Do you want Burp Proxy to stop sending out-of-scope items to the history or other Burp tools? Answering yes will avoid accumulating project data for out-of-scope items. So we want to answer yes, and what this means is that Burp is only going to be recording traffic from this IP address, so just the one that we have here. So if we wanted to take a look at this, we can click on the target tab, and the target tab has our scope. So our scope is HTTP / this IP address. So it records all of the different web pages we visited on the site, which is nice. And so let's continue. Okay, what do we got here? Target and scoping. So we can manually set a scope by using the target scope, include in scope, add button. So we would go over to, so target and then scope, and then scroll down to target scope and then click on the add button here. Let me demonstrate this. So target, from target, there's the scope sub icon here. And then, so target scope down here, so there's a, where's the add button? Exclude from scope. Hold on. This is a little bit, text is a little bit too big. Let me see if I can reduce this a little bit. Let's do display appearance. We'll make this a little bit smaller. We'll do 14-point font instead. Okay, then we'll go back. So target scope. I only see exclude from scope. Just a second. Normally I'd be able to scroll, but looks like the display seems a bit wonky. It's okay. This isn't super important. Targeting and scoping. Most of the time when you're doing like real life engagements, scoping and targeting is going to be a lot more important, but when you're learning, targeting and scoping are not really a big thing to worry about. So the next thing we're going to be talking about is proxying HTTPS. So one reason why it's preferable to use Burp's browser to proxy web traffic is because it avoids setting some setup steps such as downloading and configuring HTTPS certificates. So if you're a person who's been using Burp Suite for a long time, you know that before the Burp browser was a thing, you had to connect the Burp proxy to one of your actual web browsers, and that involves downloading a CA certificate for HTTPS pages. That was a bit of a pain in the butt. I don't actually remember how to do it anymore because I just use the Burp browser instead. So our last task in this room is to perform a web attack on the room's associated web app. So this is from another module that we're not really doing, but what we can do instead is we can demonstrate what Burp Suite looks like in action. Okay, so over at the attack box, we're going to go over to the Burp browser, which is this one over here. And what we can do is we can log into the application. So this is DVWA. It's a pretty common app for learning about web app security stuff. We need to log in. So username and password are going to be over here. The username is admin and the password is password. Okay, after we've filled this out, we click on login, and this is going to log us into the application. So I'll show you a couple of interesting things about what just happened. So remember, the username is admin and the password is password, like this. So what we can see over at Burp Suite, so if we go back to Burp Suite over here, we can go over to the proxy HTTP history tab, and we can actually see the requests we used to log into the website. So we can go over, and in the menu here, these are all the requests that we sent. They show us the host, the HTTP method it was used to access, the endpoint that was accessed, the status codes, the length, all this other stuff. If we click on the post request to login.php, we can actually take a look at this in better detail if we take a look at it inside the repeater tool. So what we can do is we can right click this request, and then we can select send to repeater. So this is going to send this to another one of the Burp Suite tools, in this case the repeater, which we can use to replay requests. So click on, right click, and then select send to repeater. You're going to see the repeater tab light up orange like this. Click on it, and then we're going to see the request. So inside of the repeater here, we can see the request information that we sent to the server, And then after we send it, we can see the response that the server sends back to us. So in here, so we don't want to see the inspector. We don't really need to pay attention to it right now. What we're going to do is we're going to put the request and the response side by side by clicking on one of these buttons over here. So we can either get the request and the response all in one window here, or you can do them side by side or one on top of the other. So this is all combined. This is side by side, request and response, and this is one on top of the other, request and response. So because we're a bit jammed in our interface here, we're going to do these side by side, and then we're going to click on send. This is going to send our post request. The interesting thing about this is that it has all the HTTP request headers here that we're sending over to the application. It also includes the username and password. So the username and password are passed as part of the request. So because this is a post request, username equals admin and password equals password. All the other parameters that we would normally use for the login are also included here. So if we send the request by clicking on the send button, so this is the response they send back to us. HTTP 1.1302 found. And so this is a redirection. So this is response 302. So everything in the 300 range is going to be a redirect. So what we can do if we wanted to is we could what is the word? We could follow the redirect over here. So there's a button over here that's labeled follow redirection. And this leads us to the get page over here. So this is a get request to index.php. And then we can send this one. And this response over here is 200 OK. So everything in the 200 range is going to be a successful request. And then we get the what is it called? The source code for the web page. But if we didn't want to take a look at the text for all this source code, what we could do is we could click on the render button over here. And the render button is going to show us what this web page looks like if it was viewed in a web browser. So click on render. And we can see the web page that's sent in response as if it were rendered in a web browser. So this is pretty handy because sometimes we don't want to just look at a bunch of text. Okay, so next, let's take a look at what a web app security challenge might look like when we're using it, interfacing it with Burp Suite. So just for brevity's sake, we're going to be interacting with this in the Burp browser. And in the Burp browser, there are a couple of things for DVWA that we need to take note of. So the first thing is we want to change the security settings on the application because they start with impossible security, which we won't be able to solve any of the challenges. If we scroll down to the bottom, or near the bottom of the menu over here, there's a tab labeled DVWA Security. So we can click on that, and then we need to modify the security level. Security level is currently impossible. Impossible is not doable, of course. We want to modify this, and we want to change this from impossible to low. So this is basically the difficulty scale of the challenges on the DVWA app. So click on low, and then click on submit. And that's going to change the security level to low so that we can start solving some challenges. So an interesting thing about this is that if we go back to Burp Suite, we can see the request that changes the security level over here. So this post request, so in proxy HTTP history, click on the post request, and we can send this to the repeater. We can see here, in the repeater, we send a post request to security.php, and the way we set the security level is we send it as data in our post request. So security equals low, and some other tokens that we're sending as well. Okay, if we send that, then it's going to send us a redirect, follow the redirection, and it sends us back to the security page over here. So if we render this out, why does it say impossible? That's kind of weird. But anyways, let's go back. So go back to the Burp Suite browser, and let's reload the page just to make sure that this is still security low. Okay, so security is set to low. That's good. Okay, what we're going to do is we're just going to take a look at what solving some of these web app security challenges might look like inside of this the DVWA app. So let's do like a simple one. Let's say that we're doing command injection. Okay, so we got command injection down here on the menu. So click on that. And then we see the interface over here. So ping a device, enter an IP address. So enter an IP address. We know that this is command injection. So this is OS command injection. This is something we covered earlier on in the course. And remember that if we see a web app here, and this web app here says ping a device, enter an IP address. So IP addresses, we don't know what IP addresses this web app has access to, but we could use like a common IP address like 127.0.0.1, which is the local host. We click on submit, and then we see this output right here. So this looks suspiciously like what you would see if you were to use the ping command from a Linux from a Linux terminal. So if we go over here, we do ping c4 127.0.0.1. Okay, we see a mess. We see our output looks like this, and the output looks almost identical to what we see in the web app. So what we see here is that we would suspect that there was some sort of, what is it called? Some sort of web function that is running an OS command. So if we suspect this, we would do OS command injection tests. And an interesting thing about the DVWA app is that if we scroll down to the bottom, there's a button that is labeled View Source, and we can actually view the source code for this particular web page. So if we click on that, this is a very nice resource for people who want to learn about secure coding, because the insecure code is illustrated over here on the View Source page. So this is vulnerabilities exec source low.php, and it shows you exactly what web source code is being used. In this case, it's running PHP over here, and what it's doing is it is running a shell exec function. So shell exec is a function in PHP that runs system commands. So the shell exec function is running ping on the target. So ping C4 on the target, and I mean we just demonstrated that earlier in the session over here. So if we suspect that OS command injection is being used on the application, we would try to run like a test payload. So our test payload would be something like semicolon and then hash symbol, and then between these two symbols here, we would put in the command that we wanted to run. In this case, the whoami command, which is going to return the name of the user that is running the commands. We click on submit, and then we see www data. So www data is like a common user for web servers, or to run the web server. Defa says, my AI
Hack the planet!
hack the planet, Defus. So Defus says, my new AI found a lot of vulnerabilities in DVWA. I let it write a report and I sent it to developers and requested CVEs for each vuln. How? Did you hear back from the DVWA developers? Let me know. But yeah, DVWA is a very well-known purposefully vulnerable application. It's very, very good for teaching all sorts of web app vulnerabilities, like these ones over here. So cross-site scripting, SQL injection, insecure captchas, OS command injection, all this good stuff. Okay, so the interesting thing here is that we can actually see these requests inside of Burp Suite as well. So if we minimize the browser, then go back to Burp Suite Community Edition here, of course, all of our requests are going to be piped through the proxy. So click on proxy and then click on HTTP history. So if we go down to the bottom here, we see our post request. So the first post request we can take a look at is the initial one we sent to the vulnerabilities exec endpoint here. Send this to the repeater. Okay, and so this is what we submit to the application. So some data, so it's the IP address equals the IP address we want to ping, I guess, and then submit equals submit. If we send this, the application will send us back our 200 OK, which includes the result of the OS command. So if we click on render, we see what this would look like if it was rendered out by a web page. So this is the result over here. And we can actually start messing around with the settings inside of the Burp Suite repeater tool. So in the repeater tool, you can go over here and you can modify the IP variable. So the IP variable will just, the argument. So the IP argument will change it to semicolon and then hash symbol. And then between that, we can put in our commands. So who am I? Make sure this is separated, and then we'll send this out. Okay, and we see here that the attack worked because we got the DVWA data back. So if you have any questions about how we use these tools, feel free to ask, to ask in the chat. I'll try to answer as best I can. I'm not a Burp Suite expert by any means, but I have been using the tool for quite a while. So any basic questions I should be able to answer. Okay, so what else could we do? So we just don't ask if they answered. Don't ask if they answered it was a joke. Haha. Anyways, so another thing we could do is we could take a look at testing other vulnerabilities inside the DVWA app. So we'll just go over to the Burp Suite browser here, and let's try some other stuff. So CSRF, SQL injection. Okay, we were talking about SQL injection earlier today. So not earlier today, but in the last couple of weeks. So we can click on the SQL injection section of the DVWA app, and then we see on this page, so this is vulnerability SQL injection. So what we want to do here is we want to figure out if there's an SQL injection vulnerability. Remember that you can test for SQL injection vulnerability on any user field by either putting in a single quote or a double quote and then submitting it to see if there's an error that comes back. So if there's an error, this is a pretty strong indication that the system is vulnerable to SQL injection. So in this case, we sent a single quote in the user field, and we got an error message back. You have an error in your SQL syntax. Okay, so this confirms that we have SQL injection vulnerability on the application. So what we would do here is we would try to figure out how many columns are returned by the request. So like a union request, we need to figure out the number of columns, and I think there are 3 columns that are returned in this original request. Once again, if you're interested in taking a look at the source code that was used to build the application or to build the page, you can scroll down to the bottom and click on the view source page over here. So this will show you the exact source code that was used to write the page. And in this case, the query that is being sent to the database is select first name, last name from users where user ID equals something something. Okay? But supposing that we didn't know about the source code, we could go back into the application, we can start doing some SQL injection queries. So we would do 1. So this is what it's expecting. And then we would do a union select query. So union select null, null, null. So this is testing for number of columns. Each one of these nulls is, represents a column that we're testing for. And we're testing for 3 columns in the original request, because it looks like there are 3 columns coming back to the application. So null, 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 and we want to comment out anything else in the original query here. So let's see if this works. The use select statements have a different number of columns, so this is good. It tells us exactly what's going wrong, and we can go back and we can just delete one of these nulls. Oh, my machine is going to expire soon. That's okay. By the time the machine expires, we'll be finished. Okay, so we're just going to delete our last null here, and we can submit this. Okay, and we see here that we get a response back. And because we get a response back, we know that this is the correct number of columns. Okay, so once again, we can start tinkering around with this inside of Burp Suite. So Burp Suite, proxy, HTTP history, and then scroll down to the bottom. You see that we sent a bunch of GET requests to vulnerabilities SQLi, this endpoint. So if we click on the last one, right click and then send it to the repeater, then click on the repeater tab here, we see that our user input is actually supplied as a URL parameter. So this is an interesting way of doing it. If we send this request, we get the 200 OK, and we can render this as a web page. So if we were doing our testing inside of Burp Suite, inside of the Burp Suite repeater, we could do it here, and we could start sending our payloads directly in the URL parameters. It's actually more comfortable to do it in the browser, so let's do it in the browser instead. So if we're doing SQL injection, I've got a little guide for this. Yeah, this one right here. So this one is a beginner's guide to SQL injection for union SQL injection. So union select injection. So for most beginner SQL injection challenges, we're either dealing with SQL injection login bypass or in-band union select SQL injection. So the first thing we need to do is we need to identify the injection point, which we did. We used the single quote or the double quote to see if the system returns an error message, which we also did. And then the second step is to determine the number of columns for the union select. So you would union select and then send a number of null columns to figure out how many columns are being returned. In our case, we were able to figure out that it's 2 columns that we're sending over. And then the third thing we need to do is we need to figure out which database management system, or DBMS, which flavor of SQL is being used by the database. So it might be MySQL, MS SQL, SQLite, etc., etc. So what we would do is we would substitute one of the columns with this function right here, the version. If this comes back, then we're probably dealing with MySQL, MariaDB, or PostgreSQL. So let's try doing this. So version, copy this, go back here. So this is the payload that worked. We're just going to replace the second null. Oh, sorry, hold on. we're going to replace the second null with the database function. Or no, was it the database function or the version function? The version function, okay. So replace null with version. And then submit. So we get this version right here. So version is going to be 5.5610 Ubuntu. And this means we're probably dealing with MariaDB, MySQL, DuariaDB, or PostgreSQL. Okay. So the other thing we could do, if we want to confirm what version of SQL is being used, is we can copy this. So just copy it and do a little bit of research over here. So this version, type in SQL, and then something should appear. So the string refers to a specific version of the MySQL database server tailored for Ubuntu 14.04. So our answer here is that the database version that is being used is MySQL, and from here, all of our subsequent commands have to be compatible with the MySQL flavor of SQL statements. So let's go back. So the fourth thing we need to do is determine the database names in the system. So this is an optional step. Although we often cannot access databases aside from the one that the app uses, it's useful for enumeration purposes, and sometimes we need to know the name of the current database to enumerate its tables. So what we would do is we would do select schema name from information schema.schemata. So select schema name from information schemata. Let's just copy this. Go back to our attack box and paste this in. And then we would put this in our payload, replacing the second column. Okay, we'll try sending this request, and then we get so we get DVWA, MySQL, and performance schema. So what we're looking at here is we're looking at the different table names. No, these are the database names. Ah, okay. So these are database names, and so DVWA is one database, information schema is another database, MySQL. I get the feeling that these are actually table names, but we should probably confirm. Okay, so the next step is to determine the name of the current database. So to get the name of the current database, we just need to use the database function over here. So for MySQL, which we confirmed that what this is, we would use the database function. So back over here. So we'd sub out the version function that we have in our current payload with database. And we see that the current database we're looking at is this one over here called DVWA. So those were database names that we're looking at. After we have the name of the current database, we could do further enumeration. And that's determining the table names in the database. In order to figure out which tables have the juicy data we're looking for, we need to know the names of all the tables in the database. So in this case, I think we're looking for a payload that looks like this. So before we run the payload, let's just talk a little bit about what the exact SQL command is. So we're looking for table name from information schema.tables, where table name equals database, so the results of the database function, and this is what we would send to figure out the names of the tables. So we'll go back in here, we will paste in our payload, and then we will include the payload in our So we'll run that, and then we've got two tables here. We've got guest book and we've got users. So these are the names of the two tables inside the database. After we have the names of the tables, we need to get the names of the columns inside the tables in order to dump out the information. Actually, what we could do from here is we could just dump out all the information from the users table. Let's just try that. Okay, let's go over here. Select, let's say, group concat. Actually, you know what? Let's do this the proper way. We'll try to figure out the names of the columns from the users table. Let's do this properly. So back here, determine the column names in the tables. Once we've identified tables that we want to look at, we need to figure out which column names exist in those tables. So this is the one for MySQL and MariaDB. So this is the one over here. We'll go back and we will paste in the payload your table name. So the table name we're looking for is users. So we'll just put that here. Table name equals users and table schema equals database. Over here, we'll replace the second column with our payload that determines the name of the columns. Submit this, and then we see here that there is user ID, first name, last name, user, password, avatar, last login, and failed login. So there's a bunch of different columns in the users table, but most of the time the only things that we're really interested in is the username and the password. So we're going to get those two columns, the user and the password. So we can go back in here, and instead of null, we're going to select user password from users. And we'll send that off. Okay, and then we get here, we've got admin, and then we've got their hash. We've got the hash for the admin user's password. We got Gordon B, another user, and then the hash for their password here. And then we got 1337, of course, as another user and their password hash. So if we were doing this as an actual security exercise, what we would do is we would take each one of these password hashes and gather them and then try to crack the hashes. All right. So of course, everything that we've been sending through the Burp Suite browser here has been recorded in the proxy tool. So in Burp Suite, if we go to proxy HTTP history, we can see all the requests that we've been sending as part of our attacks. We can go in, we can send them to the repeater, we can play around with the requests and modify them if we wanted to. But yeah, so this was a very, very rough introduction to Burp Suite. Go ahead and try this out yourself over at the DVWA room. Is this Hack the Box? It Yumiko. Hello, nice to see you, or it Yumiko? Yumiko. Hello, nice to see you here. Hack the Box. No, we're doing the Hack the Box stuff in just a second. So let's see. We just finished our Web App Basics session number 8, and we're going to be moving on to Hack the Box now. So let me put 60 minutes on the clock, and we will switch topics from topic 3 to topic 4. So, okay, so we were on topic 4, topic 5 is on deck. Okay, let's move on to the next topic. So here, I think... Oh, but before we do that, let's just talk about... let's just do the conclusion for the previous topic. Where is that? So let's talk a little bit about where you can get some more web app security education. So if we go over to our education links, where is that? Over here. This is the end of our web app security course. And what I want to do is I want to recommend to everybody some places to learn more about web app hacking. And that's going to be over here. So in this link, there are a bunch of different resources. So for example, you can learn more about web apps in the HackTheBox Intro to Web Applications module over here. There's also one from TryHackMe called How Websites Work. There's some other modules for web requests in particular, and there's one from HackTheBox. There's a 4-hour module, and if you want to learn more about web app hacking education, Portswigger Academy is probably the best resource for learning about a bunch of different web app security vulnerabilities. There's also the over-the-wire Natus challenges, which are very, very well documented. I highly recommend those. And there's also some stuff from PicoCTF, Ring Zero. A bunch of other places have web app security challenges. So this is the end of the web app security portion of HackerFrogs AfterSchool. Next week, oh sorry, not next week, but in the next session, we're going to be covering a new course. So the course we're going to be covering is digital forensics. So if you're ever interested in learning about digital forensics, about how to pick apart files and get all sorts of juicy information from them, stay tuned for this course. Okay, but anyways, we need to move on to our next topic. So the next topic is Hack the Box. So Hack the Box, here's my nom de guerre, Cyrus Hatfield. That's not actually my name. What we're going to be doing today is we're going to be doing HackTheBox Sherlocks. So the HackTheBox Sherlocks are a different type of web app security challenge. In this case, Sherlocks are thrilling investigative challenges that test your defensive security skills. We're going to be doing some of these today, and let's go ahead and do that. If you're logged into HackTheBox, and you can make an account there for free, you should be able to access the Sherlocks from this link over here. Okay, so what we're going to do is we're going to be solving some of these challenges over here. So what we're going to do is we're going to take a look at some easy challenges that are retired challenges. I think these are retired already, right? Yeah. So this is the exact type of challenge we're looking at right now. And we're going to look at this in order of rating, because we want all the best rated challenges. We sort by rating, and I think we'll try doing this challenge over here called BFT. Henki Lodwick, hello, nice to see you here. What is up? Okay, so click on BFT. If you want to solve the same challenge we're looking at right here, this is it. Okay, so while we solve this, we're also going to be trying to do a little write-up on the challenge. Hopefully it isn't too difficult. These are supposed to be the easiest challenges here, of course. Okay, let's read about the scenario. So in this Sherlock, you'll be acquainted with MFT, Master File Table Forensics. You'll be introduced to well-known tools and methodologies for analyzing NFT artifacts to identify malicious activity. During our analysis, you will utilize the NFTECMD tool to parse the provided... Oh, is this Windows stuff? You should try that ping pong box that's on HDB Season 3. It's on HDB Season. Oh, HDB Season. I mean, I'm pretty sure I can't cover that on stream. So we're dealing with MFT. MFT is Windows stuff, right? I'd prefer not to cover Windows stuff when we're on Linux, because covering Windows stuff with Linux is kind of a pain in the butt sometimes. So let's just do a quick check. Master file table. I'm on in ping pong and it's an active box. It's in an insane level box. Okay. Is this Windows or Linux? Master file table is a critical component of Windows NFTS file system. Okay, let's move on to some other stuff because we'd rather cover Linux stuff with Linux. Let's go back. Okay, Unit 42. This is also considered very easy. Fishnet. Oh, you know, Fishnet might be some email-related stuff. Let's take. Oh, and this is VIP. I can't take a look at this. Master file table is a core database of the NFT file system in Windows. Windows, yeah. Okay, so this is when VIP stuff. Fishnet. UFO 1. Okay. UFO 1 threat intelligence. Brutus, we've already covered this. Okay, campfire, very easy. Campfire. I wonder what this one is then. Campfire 2. Okay, Pharrella's network is constantly under attack. The security system raised an alert out of an old admin account requesting a ticket from KDC on a domain controller. Okay, so this is more Windows stuff. Looking for something maybe a little bit more system agnostic. So this is Campfire 1, probably also Windows stuff. Yeah, we're talking about domain controllers. Most of them are Windows. Try looking at the SOC category. So the SOC category, so let's take a look at SOC. Fishnet, compromised, Meerkat, noxious. Okay, we'll try this one. So the IDS device alerted us to a possible rogue device in the internal Active Directory network. The intrusion detection system also sends LMM and ARC traffic, which is unusual. Okay. Let's go back to... Let's take a look at this Meerkat one. So most of this stuff is Windows, huh? As a fast-growing startup, Pharrella, let's see, has been utilizing a business management platform. Unfortunately, our documentation is scarce, and our administrators aren't the most security aware. As our new security provider, we'd like to take a look at them. Okay, so good old PCAPs. All right, so let's do this one then. So this one is going to be testing our, what is it called? Wireshark capabilities. So meerkat.zip, we can download this stuff. Copy zip password to clipboard. Oh, okay. So we're just going to have to download this. So download the zip. And I think I can share this with people. Let me see if I can share this with, what is it called, Wormhole? Most attacks are on Windows, most enterprises are Windows. So that kind of makes sense. Most of them are Windows based, at least the ones you can stream. Oh, okay. So let's try sharing this the zip file on the Wormhole app, in case people wanted to try this without having an account over at HackTheBox. It might be against TOS to share, so I would be careful. Okay, maybe we won't share it then. Let's not share it, because that might be against TOS. Let's play it safe. Okay, so I guess what we need to do is we need to go over to... We need to save this to our directories. So we're going to make a directory called Meerkat. because that's the name of the challenge. And we're going to move the zip file. What's the zip file called? HTTP is kind of weird. I would look to be sure. Let's not share, because we want to make sure to be safe and not get ourselves in trouble. Okay, so here it is, meerkat.zip. We need a password. So the password is provided to us over here. So there's a button beside download files. Copy zip file to clipboard. Done that. Paste it in. Meerkat is so much fun, easy but fun. Sataniko Cadillaca? Hello, Cadillac. Sataniko Cadillac. Hello, nice to see you. I still hate the Academy UI change. So used to the old one. Okay, so we got a JSON file and we have a PCAP file. So what we need to do is we need to get the information out of here to figure out what's going on. Greetings from Argentina. Hello, nice to see you, Sataniko Cadillac. Welcome to the stream. Okay, so let's read about the scenario here. It says a fast-growing startup, Forella, has been utilizing a business management platform. Unfortunately, our documentation is scarce, and our administrators aren't the most security aware. As our new security provider, we'd like you to take a look at some PCAP and log data we have exported to confirm if we have or have not been compromised. Okay, so we're going to be answering some questions. We believe our business management platform server has been compromised. Can you confirm the name of the application running? The name of the application running. So this, the name of the application running. Okay, so we got two things in this challenge. We have a JSON file and we got a PCAP file. I guess one thing we could do is we could just take a look at the JSON file. We can't just run. Okay, this is not very easy to look at. So we would pipe this into JQ. Yeah, okay. Okay, so we've got we have a bunch of stuff here. I think what we want to do in this case is we want to maybe pipe this into alert formatted.txt, and then maybe take a look at that inside of our text editor. Okay, so this is a little bit easier to look at, not less. I mean, we could use less, I suppose. The other thing we could do is we could also take a look at we could start grepping through this and looking for suspicious keywords. Once you learn the dot syntax, it's easier to parse. The dot syntax. So JQR dot. Okay, let me give it a try. So it's JQ-R dot, and it's meerkat alerts.json. Oh, okay. So this is pretty similar to what we so like step into the array. Okay, so we're looking for, well, I mean, it looks like suspicious over here, potentially bad traffic. What they're asking us in this task is business management platform server. I mean, I'm not too sure which one is the business management platform server. I guess what we could do is we could take a look at the PCAP file. So we do that with Wireshark. We'll just have another thing. We'll call this Wireshark. We'll just run Wireshark, and what's the name of this thing? Your cat. .pcap. Yeah. Okay, so how many packets do we have? We got 8,300 packets. So that's 8,300 some odd packets. So almost 8,400. We probably want to filter these by protocol first. So we're only looking for like HTTP packets. Unless everything is TCP. Let's take a look at HTTP packets only. So this is 280. So there's only 280 HTTP packets. We got a bunch of HTTP packets and then some JSON here as well. So the first thing we want to do is we probably want to figure out the name of the business platform they're talking about. So how many different IP addresses are involved here? Okay, so this is forella.co.uk. So I'm guessing that this is the name of the company, forella.co.uk. What they want us to do is confirm the name of the application. The name of the application, Business Management Platform Server. Okay, maybe what we want to do, I think what we can do is we can, so Bonita portal homepage, login service. This gives us some interesting information about the application itself. So Bonita API portal range, login service. What are some of these other endpoints? Oh, this is interesting. Let's make this a little bit smaller. So we got username, username and password. Follow the HTTP TCP stream. That's a good idea. Okay. So we can right click and then follow HTTP stream. Okay, we'll start from stream 1. There seems to be nothing here. Huh. Can I make this text a little bit bigger? Because this text is really small. And this also seems to be... This seems to be TCP and not HTTP. But it says it's HTTP. I don't see anything. Show as ASCII. So show as raw, show as ASCII. Or like UTF-8. Yeah, these are not... Let's try like a random stream. Wrong stream? Yeah, maybe. Okay. So let's take a look at HTTP, and then this one, and we'll follow this conversation. Okay, so we see stuff here, that's good. How do we make this text bigger? So we have a username and password, which is nice. Follow HTTP stream. Let me figure out if I can change the size of the font. Wireshark. Change. What's the name of the window? Follow HTTP stream font size. Change the font size in the Wireshark Follow HTTP window. You need to adjust the main application font settings. Okay, so preferences, edit preferences, font and colors. Edit preferences, font and colors. Okay, let's do that. Edit preferences, font and colors. Okay, and we're using 11-point font. Okay, we don't want 11-point font, we want 16. Select. Apply. Okay, so we got nice and big font. And let's try following this stuff one more time. This is still small. HTTP filter, this thing, follow. Okay, that's easier to look at. Okay, so we've got our username over here and our password. So this is the username install and password install. So we got our post request to Bonita login service, furla.co.uk on port 8080. And we're looking for the name of an application that's running. So there seem to be a bunch of different people that are logging in here. So I see some different users. And we also see their passwords, which is, you know, very convenient. Okay, I think it's listed on the dashboard after HTTP after HTTP post success. So let's think about what we're looking for in this case. So we think a business management platform server has been compromised. Confirm the name of the application running. So that post is 401. It's a failed login. So we could. I mean, I guess what we could do is we could filter on everything to this endpoint. So everything, where's the endpoint? Name. So login service, so apply as filter. Let's look it up. Wireshark. Filter on endpoint name. In Wireshark, filtering by an endpoint name typically refers to identifying traffic to its resolved hostname, DNS, or specific application layer identifiers. So filtering by hostname. So to filter traffic using a resolved name, mycomputer.local. Okay, so ip.host equals hostname. Filtering by domain website name, I mean, the other thing we could do is we could look for stuff that contains login service. So we could look for packet details, string value, login service. Okay, so these are all of the, how many of these are there? We probably want to apply this as a filter. Why not grep the applications on the downloaded files first? Oh, you know what? That's another way we could do this. Cypher, yeah, that's a good point. So then, one thing that we could do is we could take a look at the exported objects in the packet packet capture. So look for exported objects from HTTP. Oh, well, we got quite a few of these. What are these? So the file name here is all login service, except for a couple of them. Oh, interesting. It looks like we got some remote command execution. So so this is packet 22932. How do we go straight there? Cancel. Hold on. Where's that? I can't click on this right now because I'm in the middle of this. Cancel. I'm looking for packet 2932. So where's that? Go to packet 2932. Okay, where's that number? Okay, we're here. Okay, so in this packet, so this is a JSON file. So in the JSON file, they've got who am I? So some sort of RCE going on here. So command equals who am I, and then output is root. Huh. So let's take a closer look at this. So this is HTTP. Is there a way we can export a specific packet? So we'll try adding a comment here. So because this is an interesting packet, we've got RCE here. Okay, and we've got packet comments. So what's this endpoint? So this is it's an API. So /bonita/API/extension. We can save any of the data in the view. Okay, so I mean we got this packet commented. Let's take a look at some of the other files from HTTP. We found one interesting one already. So we'll filter by file name. login service. We've got our nmap. Why is there an nmap thing over here? That's kind of weird. Okay, so this is packet 4193. Any one of these we could potentially export and save as, right? So we can try saving this. So this is a .deb file. Huh. So they're downloading a Debian package, an nmap Debian package. Anyways, we'll try saving it. Okay, and then we'll take a look at this over here. Yeah, so this thing here, this is like a Debian package, right? Oh, this is a compressed Debian binary package with control. Okay. So yeah, so this is nmap. So for some reason, nmap is involved. apt installer, it's double compressed. Okay, let's take another look. So this is, yeah, so the host name is different. So what they're doing is they're sending API JSON requests, and they're sending RCE. Who am I? We got our bash command over here. Let's try saving this. So this will save out as like a JSON file, right? Ooh, okay, save. So this thing is just some JSON information. JSON text data. So what does this look like? We can try catting it out. Pipe into JQ. Yeah, so they're running some sort of bash command. The output here kind of reminds me of like wget. Wget or curl, some sort of like downloads command. Let's see. We might as well download these other files as well. So this was the one that runs the who am I command, and this one runs the password command. This one's pretty big. Oh, this is the contents of the password file. Okay, let's take a look. So the password file, yeah. So this is the contents of the password file. I'm guessing from the web server that the attackers are trying to exfiltrate. We're not really any closer to figuring out the name of the application that's being run though. Because what we're trying to figure out is confirm the name of the application running. Claretto, hello, nice to see you here. I saw that you've been doing a lot of stuff over at TryHackMe. It's been showing up in my feed. But hello, nice to see you here. Confirm the name of the application. So I don't see any names of applications over here. We know that the application ends in the letter T. So task 2. We believe the attacker may have used a subset of a brute force attack category. What is the name of the attack being carried out? Huh. Brute force attacking category. What is the name of the attack carried out? So, I mean, this is just a guess, because we saw the person export the password file. Many applications identify themselves in the initial contact. Many applications identify themselves in the initial contact. Hanky Lodwick says the application usually listed after login success like copyright. So filter dashboard. Dashboard? Satanic says, Satanical Cadillac says, for the first question, so this is like password brute forcing? No, hash cracking. Password cracking? Or hash cracking, something. What are some of the other ones? This vulnerability exploited to have a CVE. Okay. Many applications identify themselves in their initial contact. Okay, so before we do this, let's take a look at the last JSON file that we found over here. So this is the there's a who am I command. So this comes back as command in this, and then root comes out here. So the JSON object that is returned from the RCE is going to show up as out in this. So we can do the same thing over here. Look for the out, look for the command. Yeah, so out is so is this the name of the program that they uploaded to the target? Okay, I did some research on Bonita and found the answer for the first question. The answer for the first question. Did some research on Bonita. Bonita. Wait, is the answer Bonita? No, it's a bit too short for this thing over here. So it's a Bonita. Is the name of the app called Bonita? Bonita Soft. Bonita Soft? Bonita Studio. Because we saw that the there's a bunch of there's an endpoint called Bonita. Okay, let's try this as the answer. Yeah. Bonita Soft. Huh. So if we go back to Wireshark and we look for Bonita Soft, the answer is probably going to show up in those packets. Compromised? What are we talking about? Do you get the access logs from host compromised? From host compromised. There was a host named compromised. Okay, so if we know that the name of the application is called Bonita Soft, let's see, find. So we look for this string. No packet. So there's no packets with Bonita Soft specifically. Okay, arrived now trying to understand what happened. Yeah, so we're doing this challenge over here from HackTheBox. What is the second question? So the second question in our scenario is, we believe the attacker may have used a subset of the brute force attack category. What is the name of the attack carried out? Brute force attack. So there's 7 critical events in the JSON file. So if we look, we got the JSON file over here, we formatted it. We can look for critical. Directory listing may be for the enumeration endpoint. So what we need to do is we need to figure out the severity. So maybe we need to figure out something severity 3 or severity 4 if there are like high severity events. So we can look for so this shows us severity 2. Is there severity 3? Is there severity 4? Severity 4 doesn't exist. So the highest level severity events are severity 3, and there's a lot of them. So I don't know if looking for severity 3 is the logical thing to do, but we can grep this and so we got signature inbound, user agent info, alert, action allowed, category miscellaneous activity. Our password spraying, it's about brute force. Yeah, this might be password spraying. So if it's password spraying, we're looking for a bunch of connections to the same endpoint, and we saw a bunch of different connections to the login endpoint. So let's look for HTTP, and we're looking for the endpoint Bonita login service. So how can we apply the filter? Apply as filter, Bonita login service, selected. So these are all of, well, I mean, there's a bunch of them, right? How many of these are we looking at? We're looking at 118 different connections to Bonita login service. Okay, I know why I can't before. I mean, this kind of like an instinct, I guess. What are we looking for? Destination IP. I mean, this. So we see that the usernames and the password. So username equals install, password equals install. Huh. Username equals install. Oh, interesting. So between each one of these attempts, we see that they use the username install and password install. So we could probably look up this vulnerability. So Bonita app install vulnerability. Okay, a critical authorization bypass vulnerability affects Bonita web versions 2021.2 and earlier. The vulnerability allows unauthenticated or low privileged users to bypass API authorization filters and perform privileged actions, potentially leading to remote code execution on the server. Okay, so I think one of the questions might have been to... But yeah. Okay, so it might be password spraying, probably. From the PCAP, we know that the attacker did brute forcing on the credentials. So, password spraying? Okay, it's not password spraying. It's got to be something else. So what other type of... So does the vulnerability exploited have a CVE assigned? If so, which one? So I think we're looking for this CVE right here. So yeah. Let's go back and submit this. What string was appended to the API URL path to bypass the authorization filter by the attacker's exploit? Okay, so it looks like the server is busy. How many combinations of usernames and passwords were used in the initial credential stuffing? They gave us the answer. They gave us the answer, so the answer here is credential stuffing. But, I mean, credential stuffing and password stuffing are kind of two things that mean the same thing. Okay, so this is the CV we think is associated. Yeah, this is it. Brute forcing attacks include simple guessing, dictionary attacks, hybrid approaches, credential stuffing, and reverse brute force. Huh. I don't think I've heard of reverse brute force before, unless it goes under a different name. But yeah. Satanico, thank you. Thank you very much for the advice. Okay. So what string was appended to the API URL path to bypass the authorization filter by the attacker's exploit? Press enter with no special characters. Please enter with no special characters. Okay. What string was appended to the API URL path? I mean, we probably can figure it out if we take a look at the blog post over here. So let's just take a look. Authorization bypass in RCE. So does it say which string is used? The following authorization filters specify an exclude pattern parameter of I18N translation. I18N translation, is this the string we're looking for? Pass the parameter to two different filter classes: REST API authorization filter and token validation filter. Validator filter. Okay. Taking a look at these filters, they extend the abstract authorization filter. Okay, so they run some sort of Python script here. All right, let's try submitting the string that we found from that blog article. So this one here, submit. Yeah, that was what we're looking for. Okay, the next task is how many combinations of username passwords were used in the credential stuffing attack? Combinations of usernames and passwords. So we see 118 packets displayed over here when we filter by the login service. Install, username install, and password install. I wish I could export all of these. As far as like how many combinations? So the number of combinations. So the answer is going to be a 2-digit number, even though the number of displayed 118. So we got 118. Severity level. Okay, second in mind. Let me try your command over here. So this is the JQ command, running it on meerkatalerts.json. Login attempts. So there's login attempts that are recorded over here, and we need to record the number of events here. Then you can do word count L. So pipe all of this into word count how many lines. So we got 63 lines. not quite 60 more. There's probably more under different severities. Okay, so we'd look for... So severity level 1. So maybe just look for login attempts. So we don't necessarily need to just look at miracast.json and then grep out login attempts. So just this. So cat, there's only one login attempt. Hold on. Okay, so we need to, we'll separate this into JQ and then look for these login attempts. Possible staging for CVE 2021. Interesting. It's really interesting that that whatever system they have here identifies what CVE might be being abused. Could be off by 1, 63, off by 1 error. Could be 62. No. Okay, so we've got all these login attempts. We'll try word count by line. 63. So this is 63. We tried submitting 63, it didn't work. How many combinations of username and passwords were used in the credential stuffing attack? So the log, that log is a Suricata EVE formatted, I guess. Possible staging for login attempt M1. Let's just look for these ones for that indicate possible staging, because I think (63). So these, it's the exact same number. We need unique combinations. So unique combinations means unique combinations are going to be less. How many combinations of usernames, passwords are used in the credential stuffing attack? So we need to get all the unique usernames and then all the unique passwords. I guess we need to get all the unique usernames. The format I sent you has more than one user. Hold on. So we go back in here. So get all the login requests in one file. Filter the PCAP for post and URI to login endpoint. Filter the PCAP for posts and then URI to login API endpoint. Okay, so if we go back to Wireshark, we look for, this is the login endpoint. So these are all posts. Let's see if there are any that are not. How many are being displayed? Post Bonita login service. But I mean, there's 118 displayed. We need to filter this down some more. You need to add a pre-filter first. The pre-filter. What does that look like? Okay, login attempt. Oh, from a specific IP address. Okay, so if we take a look at this command, there's only 57. So the difference is that we're only looking for one specific IP address. Check the login if it uses the username or length. Okay, so let's Let's filter by this IP address. So the destination, it would be the source, right? So it would go back to so something like this. No. How do we filter by source IP? So Wireshark filter by source IP address. IP dot source underscore host. Okay, okay. IP dot source underscore host. So they've got more stuff displayed now. More stuff displayed. Then off by 156. Huh. So we can't... So the suspicious IP is this one, right? The problem is that the filter doesn't show us. I mean, it works here. So we're looking only for this stuff. I wonder if we could do it with just some like simple grep. So we grep like login attempt. So catout meerkat alerts.json, grep login attempt, and then grep for this thing. Oh, I guess we need to pipe this into JQ first. Okay, this isn't going to work because it doesn't... So JQ grep login attempt, and then combined, let's say 10. Okay, so this does get what we're looking for. None of the requests are logins. So we do login attempt, and then we do grep C10, right? So C10 will get the first and last. Yeah, so source IP, this thing. And then grep this, and then this gives us 57, but we're looking for 56. So we go back to try hack me, and we can submit 56. And that's what they were looking for. So what username and password combination was successful? It's off by 1. Okay, so how many more questions do we have over here? I'm not too sure if we're going to be able to finish this before we move on to the next thing. But you know what? We'll spend a little bit more time working with this. Let's do another 15 minutes. Because we got a lot of time for our last task. Okay, 15 minutes on the clock. Which username and password combination was successful? So in the format username and password. So we just need to, especially not when the time ran out. Okay, so username password successful. We just need to go back into Wireshark. And then we need to look for the response that doesn't come back. We got our source, we got our destination. We just need to return a response code that's different. A response code that's different. How can we tell the 302? So the length is if we filter by the length, there's a couple that that are a bit larger than most of them, but this is just the contents of the request. We don't know about what the response was. I think what we can do here is we can just get rid of the source filter. So this comes back more. We go length here. So I'm guessing that there would be destination and source would be reversed, but I don't know if that's followed. Okay, so Wireshark filter by HTTP response code. Okay, so to filter traffic by HTTP response codes in Wireshark, use the following display filters in the filter bar at the top of the window. So specific response, specific status code, error codes. HTTP response code equals 200. So like 302 for redirect. Okay, so HTTP response code equals something. Let's go back in, get rid of this. So we're looking for the redirect, 302. Okay, so we see the redirect here. What is the... source destination? Okay. So this, I mean, this looks good. The problem is we don't, oh, we probably want to follow the conversation in this case, right? So this was a successful login. Refer header. So where's the refer header in here? I don't see one. We have location. Redirect your URL, Bonita, portal, something something. Segfaults, hello, nice to see you here. What is up? So Bonita login.jsp. So let's take a look at let's follow the HTTP stream. So this one is HTTP 302. So it just shows us the 302. It doesn't show us the previous request. Yeah, it doesn't show us. Follow the stream. Yeah, trying to. Okay, so that's following the stream. We're looking for 302 specifically. I think we're taking a look at the first one. Let's take a look at the second one. Filter by the endpoint login service and the response 200. Response endpoint login service and response 200. So 200 and then the login service endpoint. What was that? Wireshark filter by endpoint? Well, the other way we could do this is we could try searching for stuff inside of here as well. So look here, look for login service. Nothing here. So login. Okay, I used this Wireshark filter, went to the last post request. The last post request. You know, that's a good idea. The one that logs you in is probably going to be the last post request in the list, right? Okay, IP source hosts this thing. Okay, let's try this. Cancel. Protocol HTTP. And then look for last parentheses missing. Yeah. Or looking for a set cookie header. That's often a giveaway too. Set cookie header? Yeah, that's a good point. Okay, so if we look at the last post login request to this thing, how many? We're looking at 200 post Bonita. So these are page upload. It's the wrong endpoint. We're looking for a post request to the Bonita login service. So the last one here is install password install. I think that's not going to be it. But seem to be a lot of them though. Rearrange the packets by the packet number. So packet number. Okay, and then go to the bottom of post requests for Bonita login service. Looks like the last one was this one. So username seb.broom. Okay, let's copy this. So let's see. Copy as ASCII text. And we'll just put it up in here. API response was 204. 204. Okay, so username seb.broom at forella.uk. whatever. And the password is government. Government? Okay. So, just like this. sebbroom forella.co.uk, password government. Let's try giving this as the answer. That was the correct answer. Okay, if any, which text sharing site did the attacker utilize? Text sharing site, huh? Pushing feds under the bus. Which text sharing site did the attackers utilize? So something.io. What is a text sharing site that ends in .io? Text sharing site something.io. Pastebin? Share text. Sharetext.io? I mean, this is just a stab in the dark. But it looks like it's not the right number of characters. Share text. We could look for .io in the in Pastebin. No, sorry, in Wireshark. So we can look for that pattern. So we're looking just for HTTP requests. Yeah, like .io. So string is going to be .io. And what do we got? Pastes.io. So we see it over here. https://pastes.io. So let's submit this as the answer. Pastes. I've never used this before. Okay, that's the correct answer. Please provide the file name of the public key used by the attacker to gain persistence on the host. The file name of the public key. The file name of the public key. What could this be? We could look for like public key as like a keyword. Either key or public key. Public is, well, key might, I'm not too sure. Okay, so look for key. We've got a bunch of different keys. Okay, maybe we need to look for the word public. Okay, so there's nothing containing the word key. There's a bunch of these keys. Yeah, there's a lot of this stuff. Yeah, ID RSA. ID underscore. No, or RSA. Did we find one? Or look for authorized keys as its target. Authorized keys. Authorized keys. One thing that kind of springs to mind for this is what we found over here. The contents of this stuff. So the command who am I or command bash. Bash something something. Why would you run bash on some like randomly named file over here? The other thing we could look for is we could look for more file contents. So export objects. So there's no FTP, there's no FTP stuff. Everything's all the file contents are going to be in HTTP. Okay. So we got a bunch of what is in that file. That was just like a JSON command. Actually, what's in the file? Not sure. We have our nmap stuff here. We have our RCE. Yeah, what is this thing? What is this file? We executed this file. Multi-part form data, login service stuff. Let's try saving this. So just save it to here. I have a feeling it's like some sort of executable file. Maybe that something is a bash script. Yeah, this might be a bash script. Let's identify it first. JSON text data. Oh, okay. Well. Paste.io. So what's being... Okay, we got an HTTPS address. We could take a look at this. If it still exists. It might have been deleted because, you know, this thing... Paste.io. Expired paste. Yeah, so we can't see it. Alright, let's do another 15 minutes and see if we're able to make any progress on this. What are the other questions? Please provide the file name of the public key used by the attacker to gain persistence on the host. So persistence... You missed one character on the paste. Did I? Paste.io raw, HTTPS. Okay, let's try doing this again. Copy. Ah, okay. We've got curl. So run. So this is another file. So we redirect output into SSH authorized keys. Is the contents not in the capture? Well, I think we're getting somewhere here. The name of the public key used by the attacker to gain persistence on the host. The name of the public key. Why restart SSH? That's weird. Pseudo service SSH restart. Yeah, I'm not... The second paste is this. Okay, let's take a look at the second paste. So this is the key. This is the key itself, but we're looking for the name of the file. Is this the name of the file? This this endpoint name? Yeah, that's what they're looking for. Okay, great. All right, I think we're getting close. There's only a couple of questions left. Can you confirm the file modified by the attacker to gain persistence? Confirm the file. Example file path. So what did they modify? They modified the authorized keys, didn't they? So home ubuntu.sh authorized keys. So they're looking for the full file path? Example file path. Okay, so let's just copy that. And then submit it here. Okay, and then last one. Can you confirm the MITRE technique ID of this type of persistence mechanism? Okay, so MITRE technique ID, I guess we just search for this and then add something like add SSH key. Okay, the MITRE attack ID for adding an SSH key to maintain persistent unauthorized access is T, this one over here, account manipulation, SSH authorized keys. So I think this is what we're looking for. So they're looking for a three characters after this. Okay, I think this is it. Okay, we're done. Great. We finished our Sherlock. All right, everybody. Yeah. So if you want to do the same stuff that we were doing, this is the link over here. It's a pretty fun challenge. I don't know if we did it exactly the way it was intended, but thank you very much to Sick in the Mind and SysOS Master for assistance. Don't know if I could have done it without you guys. Okay, that's great. Let's move on to the last challenge of the day then. So the last challenge we're doing today is we're continuing on with this box over here from HackTheBox. No. It was thanks to the dude that wrote JQ, to be honest. For sure, for sure. Okay, so HackMyVM. Anonymous. We're looking at latest was a lie. So is there a direct link on here? Yeah, okay. So if you want to do the same thing that we're doing this challenge over here. Is that challenge for VIP or for free accounts? You can do it for free. I mean, I don't have an account. I don't have a, what is it called? I don't have a paid account over at HackTheBox. So you can do this one for free. Okay, so let's talk about this box that we're going to be covering. It's called Latestwasalie, and let me log in first, because this one is proven to be a very interesting box. If you're logged into HackMyVM, this is the link. And let me go ahead and, what is it called? Let me start up the machine. So first of all, I'll talk about what we've already done on this box. I've got it over on my walkthroughs for HackMyVM. Linux box, easy. This one was Latestwasalie. Okay, so let's talk about what's going on in this box. Oh, you know what we should do? We should update our overlays. Okay, so we're doing topic number 5 now. Topic 4 is done, topic 5 is here. And we'll put 100 minutes on the clock, and we'll see if we can finish it within 100 minutes. Okay, and you know what we can do? We can put on some new music, because I really want to listen to the Void Stranger soundtrack. It's got some really nice music. Let's do that. Agent 57, hello, nice to see you here. What is up? Okay, so on this box, what are we dealing with? So we need to do some Docker registry hacking. So brute forcing Docker registry basic authentication, enumerating Docker registry catalog, enumerating Docker manifests, OCI indexes in the manifest. So OCI indexes is something that's new to me. I'm not super familiar with how Docker works, but I had to do a bit of research about Docker to solve this challenge. So in this box, there are 3 ports open. There's port 22, port 80, and port 5000. Let me go ahead and get the IP address of this box so that we can recreate what we've done so far. The other thing we're going to do is we're just going to get out of Wireshark because we're not using it anymore. Okay, so we're doing some Nmap port scanning over here. So let's do the scan on the 38 box, the 38 IP address. So we got 3 ports open. We got 22, we've got 80, and we got 5000. So the app on port 80 has a comment at the bottom of the source code which we interpret as a username, ADM. So let's go ahead and access the, whoops, what's the IP address? This one over here. Okay, so it says default site, no application configured for this host. Check the available files on the server. Check the available files on the server. So what we're redirected to is this application right here, WLAL platform, and we also get a domain name, so latestwasalie.hmv. So what we did was we added this to our etc host file. So if we go over to here, we added latestwasalie.hmv to this particular IP address, which means we can resolve this domain correctly. So after that, what we did was we took a look at the source code for this page. So view page source, okay, and down at the bottom of this web page, we saw this comment here. So latest deployment on April 6, 2026 by ADM. So ADM we interpreted as a username, and then we took a look at the application on port 5000. So the application on port 5000 was reported by Nmap as a Docker registry application. So Docker registries are basically, what is it called? They're repositories for Docker images. And there are very specific ways of enumerating them. If you go over to the application on port 5000, and you go over to v2/catalog, what this endpoint usually is on the Docker registry applications list of Docker images on a registry site. So this is the endpoint over here, v2 catalog. So if we try to visit this, we're greeted with the basic authorization login prompt. So username and password. So apparently this is standard. This is pretty standard for Docker registry. If you want to password protect your Docker registry, you have to set up basic auth. And in this case, we've got a username. So the username is ADM. The password we don't know. We need to do some brute forcing attacks. So brute forcing basic auth. And where did I put that thing? Here. So when we attempt to enumerate the Docker registry app, we run into two problems. So the first problem is the app requires basic auth login, and we can use Hydra to brute force the password with the ADM user that we found earlier. So SysOS says all other auths take a lot more effort to set up, so basic auth it is. So we got Hydra over here. We can run this Hydra command. For the longest time, I had a lot of problems trying to do brute force attacks with basic auth. But yeah, so this is the one that's worked for me. If you guys want to steal it, you can go ahead and try. So we go back into our fuzzing over here. We just run this. Okay, so this is going to do some basic auth brute force with the ADM user using our good old trusty rocku.txt list with 14 million passwords. And we were able to find a correct login. So it's login ADM password lover 1. So if we go back to the application, type in ADM as the username, lover 1 as the password, we're now able to access the catalog. So the catalog lets us know what repositories exist. So there's one repository in the registry. It's Latestwasalie-web. So what we would normally do from here is we would try to figure out what's in this Docker image. So the other problem here is that the server is not HTTPS. So we have to edit a Docker config file to accept the server as an insecure one. Add the following to etc docker daemon.json. So insecure registries, the IP address, and then the port number over here in a JSON object. So after this, we need to restart the daemon and the Docker. So reset daemon, daemon reload, restart Docker, and then we can log into the Docker registry. So Docker login to here, and then we can navigate to the following endpoint on Docker registry to find out what containers it's hosting. So yeah, so we just did that. From here, there's a bunch of other commands that we need to figure out, because the next step is to take a look at the manifest. So let me do a little bit of digging around. So Docker CLI manifest. So the Docker manifest command is used to manage image manifests and manifest lists, which are primarily used to create multi-architecture images. Multi-architecture images, a single image tag that works on both x86 and ARM64. Okay, so the manifest is a JSON file containing information about an image's layers, size, digest, and OS architecture it was built for. So, So Docker manifest, I think I might have the command saved. Let's see if I can. No, I don't have it. Oh, I do have it saved. Okay, so sudo docker manifest inspect insecure, and then we look at the manifest for this repository. So Latestwasalie -web latest. So if we do this, then we see that this is an OCI manifest, which is different from typical Docker manifests, apparently. So this is the type of manifest for multi-images? No, multi-architecture Docker images. So schema version 2, application VND, OCI image, index v1 JSON. So what we need to do is we need to download, it's the new standard for open container initiative formats. So what we need to do from here is we need to get the digest for this one right here. Application VN, let's see, this one here, that has this size for architecture AMD 64, OS Linux. That's good because that's what we're dealing with right now. So we want to pull just the manifest, or just pull the file from the manifest, right? I think I was working with our good friend the AI to try to figure out how to do this. So the digest number is over here. So Docker download, I think it was like, this is called like a blob by, let's see, what is this called? By digest. Okay, downloading a Docker blob by digest involves interacting with the Docker registry, HTTP API v2. Blobs represent immutable image layers or configuration objects identified by a unique SHA-256 hash. Identify the blob digest. Okay, download via HTTP API. So once you have the digest, use the following endpoint structure to download the blob. So we just access this via the web browser. We don't use the CLI. So get v2 name blob digest. So if we were to plug this in, hold on. Okay, so v2 name blob digest. So the name in this case is going to be Latestwasalie web. And we're looking for blobs, and then digest name is going to be this one over here. Okay, so if we... let's try to navigate to this endpoint and see what happens. Page not found. Okay, so what are they looking for? So get v2 name blobs digest. Oh, okay. You need the SHA-256 attached to this as well. Okay, so we'll just go back and then we'll put SHA-256 onto the name. Okay, so we got an error, blob unknown to registry, but digest type is kind of important. Okay. So we get blob unknown to registry, but it's not 404, but it is blob unknown. I have no idea what this really means. So the raw data is this. So the other question is, how would we access this from the CLI, like a CLI command? Pulling a full image by digest. If your goal is to download a specific version of the entire image rather than a single layer, use the docker pull command with the image. What was it? With the image digest to ensure reproducibility and security. So docker pull image name at SHA-256 digest. Okay, let's try this then. So good old docker pull, and then we need to specify the name. I think this is latest was lie.hmv. Docker pull registry image. So this is on port 5000. Server gave HTTP response to HTTPS. Oh, this has to be insecure. So, okay. And we also have to run it with Pseudo because I'm not part of the Pseudo group. I'm not part of the Docker group. Okay, server gave HTTP response to HTTPS client. Oh, didn't we already log in? Sudo docker login. Yeah, so login here. Login succeeded, okay, and then do the same thing. Huh. Oh, we need to add this insecure tag. -- insecure. Unknown flag insecure. Because I'm pretty sure I've already added this to... HTTP server gave HTTP response to HTTPS client. No, they don't like this. You have to add it to the config if the name matches. It would not. If the name matches, it would work. Okay, so let's check the. Let's check the registry for the insecure stuff. Over here. It would be the etc. docker daemon.json file. Okay, let's check it. Oh, okay. I think I need to use the IP address instead of the domain name. Okay. Error response, manifest unknown. Manifest unknown. Error response from daemon, manifest for this thing. Latest web blobs. Oh, I forgot to add the SHA whatever to it. Was it SHA 256? Yeah, SHA 256. Still says manifest on loan. Like, get a lot more info like v2 to Docker. So we don't need v2. We just need Latestwasalie. Manifest unknown. I mean, this might be Latestwasalie web latest. Invalid reference format. Okay, we need to struggle with syntax. So first of all, let's double check this. So the digest I want to access is this thing. We'll save this out to digest.txt, maybe. Okay, so our good friend the AI says pulling a full image by digest. Docker pull image name. Docker pull image name at SHA-256 digest. So in this case, it would be let's make the command. Docker pull Latestwasalie web and then at 256 digest something. Did this work? No. Repository does not exist or may require Docker login denied. Requested access to the resources denied. We logged in, right? Docker login. We did this. Okay, so y.registry address port registry repository name. did WQE log in for the domain or the IP? So I mean, I'm pretty sure we're logged in for the IP address. Docker pull registry address port. Registry address port. So Latestwasalie web be like IP address 122.38.5000 / latest. Okay, so we got something. So pulling from Latestwasalie web, digest this thing, status downloaded newer image for this thing. Okay, so I mean, it worked. Now we want to access the image. So we can run the image, or we can... I'm gonna save this command because I'm gonna need it for my notes later. Hold on. Let me make a little text file to paste this into. Okay, so this box was called Latestwasalie. Sorry, everybody. I just need to start keeping track of some notes. Okay, so we just pulled this image. We just need to run the image. I'm pretty sure I kept some similar notes for another machine from HackMyVM called like doll. Yeah, this one over here. So Docker pull, and then enter the container with the shell as root, Docker run, okay, let's give it a try. So Docker run -it. So run this thing. I mean, can we just use this full thing? Okay, we're in here. So we're the www data user. Huh. Why are we the www data user? Is there not an inspect command? I mean, there might be an inspect command. Actually, wait, inspect might be the better way to do this. Because if we run inspect, then we can take a look at all the changes that was done to the image. All right. Okay. So yeah, so that we can probably want to take a look at the image history for this thing. So Docker image history. Okay, let's exit out of here. So Docker image history on this thing. Okay. User www data. So we got some keys here. Docker entry point. So it looks like the full commands are missing. I think there's another switch we can do to get the commands in verbose form. So like Docker image history. Help. So no truncate. Do not truncate output. So no trunk. JSON. I think we just need to add like no trunk to the output, and we might be able to see some extra stuff. And I guess on top of this, we can just output to some new file. Output to image history.txt. Okay, so we see the full commands over here. Some of them are pretty long. So I think what I want to do is I want to delete the first column here. So cat, I think it was like cut D. Cut by delimiter space. Return field 3. Field 2. Field 1. Okay. I wonder what the best way... Oh, there's also the thing that deletes all of the white space, right? Because if we run nano on this, it looks different. We might want to separate on field AGO, and then we can just get everything after AGO. So a go. Delimiter must be a single character. Okay, so that doesn't work. Because we just want everything. So are these tabs? These are spaces. These are all spaces, but how many spaces are we counting here? I mean, I don't really want to count these. Space, what's the best way to do this? I guess we could count. This can't be the way to do it. If we just delete all of the white space, that doesn't really help us either. I mean, I guess it gets closer. But if we delete all the white space, it becomes really hard to read. I wonder if there's like some sort of switch we could do on image history, or what was it? The image history command here. So there's no trunk. Let me take a look at and see if there are other like switches we could use. So format string, format output using a custom template. Okay, I think this is what we want. We want to format the string in JSON format. Yeah, so if we output it in JSON format, that might be the better way to go. So SOS Master, that's probably the way we want to do it. So no trunk and JSON format string. This looks weird. So refer to docs.docker go formatting for more information about formatting output with templates. Is it just ... format? Maybe format and then JSON like this. Okay, so this does output it in JSON format. We just need to start JQing through this thing. It's called experience wonky tools. Oh, you know, invalid something something. Huh. So we want to get the comments. We want to only get the comments, I think. Comment created by. I think we want to just get created by. But why doesn't why can't we pipe this into JQ? Invalid numeric literal at line 1, column 6. Because I do see some good commands in here. So if we just cat this, this is just a big mess. What were the other formats available? So I got table, print output in table format with column headers, default. Table template, print output in table format with a given Go template, JSON, and then template. Invalid numeric literal at line 1, column 6. Line 1, column 6. Okay. Parrot, our Sam Ploris, hello, nice to see you here. Are you asking why I'm not using Parrot OS? Oh, you know what? I think I know what the problem is. So I appended the image history.txt instead of overwriting. So that's why the JSON didn't work. So cat this thing, pipe JQ. Okay, good. Okay, so we want to get only created by. So we can grep by created by. Okay, so these are all the commands. Man, this looks pretty gnarly. Do you work in the cybersecurity industry? You talking to me, agent? Or are you talking to somebody else? If you're talking to me, I did work in the cybersecurity industry as a web app security tester for about half a year. And then I decided that I wanted to do education stuff instead. Okay, so let's just... AMD out. Debian.sh, Arch, AMD64 out, Trixie. Trixie. Is Trixie the name of the user in this case? Let's put this into command history. We'll... Okay. So this is still some really long output. But Agent 57, yeah, I mean, I've seen you around like different streams, but hello, nice to see you here. How did you educate and stream? So do you teach at a college or school? I mean, I teach online. I teach on Twitch and I teach on YouTube. I publish, like, you know, education content for beginner cybersecurity stuff. Okay, so we're running some sort of... entry point, Dockers... C flags... Maybe I can cat this out instead. I'm looking for either a username or a password. Or maybe some other important information in here, not too sure. Okay, lurk from time to time, I've done for a while now. Yeah, Agent 57, I think I've seen you in other people's streams, like Pebble, or like Pebble and Theo's stream? Password was probably the last line of the file. Last line of the file. The password was probably the last line of the file. Okay, let's take a closer look at this. Said more that you did not see. Oh. Was Samploris saying some bad stuff? I didn't see it. It was in Portuguese and Automod caught it. Oh, okay. Let's see. So PHP version something something. I mean, the version of PHP being used isn't vulnerable or anything, is it? Let's see. PHP version is usually not vulnerable, but I don't know. Weird things can happen. Yeah, not this version of PHP. Okay, so password was probably the last line of the file. Last line of the file. Yeah, I don't see anything here. Could it be that there were other things that I needed to? Thought it was that Trixie and password, but it might be way off. So Trixie, and then this is the password? I mean, I don't know. We could try logging in. So SSH at, so Trixie at this IP address. And then put in the password. Seems like an unlikely password. Nah, it doesn't look like it. Okay, so there's... The last time I was looking at this, I saw some other stuff as well. So there were there was other stuff in the manifest. Let's go back to the to Docker over here. So we were taking a look at the manifest for this thing. Manifest, inspect, and secure. So there's this larger thing that we... You know what? Maybe we need to take a look at this smaller thing as well. So this is only... This is a much smaller file. Maybe I need to take a look at this. Okay. So it's architecture unknown, OS unknown. We'll go back in. And we'll do the docker pull command. Where's my docker pull? Okay. And then I'd begin with the unknown one. Yeah, let's try this. Okay, unsupported media type. Unsupported media type, application VND something something. So this was... Well, I mean, this is the same media type, though, if this is what we're talking about. Do I have my formatting correct, or my syntax? Architecture and OS. Is the architecture and OS the problem here? So docker pull doesn't work. Can we do, like, image history from here without pulling them, without pulling it first? No such image. Okay, they are unknown. Architecture and OS unknown. So let's try asking our good friend the AI. How do we interact with these Docker manifest contents? Let's do a new one. How do we interact with these Docker manifest contents? Okay, and then okay, so you interact with those manifest entries mostly by using OCI compatible tooling. So Docker container D, ORAS registries, and the spec itself to inspect, fetch, or manipulate the reference blobs and images. Below is what the snippet means and how you can actually use it. So media type, application VN, blah, blah, blah. Okay, this is an OCI image manifest, not a manifest list index. What? It points to a configuration blob and a list of layers for one image variant. Points to a config blob and a list of layers. So raw size of the manifest blob in bytes. Content addressable ID of the manifest. You can fetch it from the registry using this digest. Okay, so platform architecture unknown. This entry is not tied to a concrete CPU, arch, or OS. It is effectively a placeholder or generic component. How to inspect and fetch it. Okay, so on the CLI, you typically inspect the manifest. If you control or have access to the registry, use docker manifest inspect. Docker manifest inspect. Okay, image tag verbose. This will show you the manifest JSON, including the config and layer entries, each with their own media type, size, and digest. Fetch the manifest directly by digest. If you only have the digest and know the repo, you can download it via the registry API or Crane. Crane? I mean, do we have this tool? No, we don't. Fetching the underlying blobs. The manifest references a config blob. Okay, and then layer blobs. Neems, hello, nice to see you here. What is up? You can then use Crane blob fetch. Download them by the digests. How to modify or reassemble manifests. If you're hacking on images, OCI tooling. If you paste the full manifest with config and layers, I can show you the exact CLI commands tailored for the specific output. Okay, sure, why not? Okay, so this is manifest stuff over here. Crane. What is Crane used for? Okay, you're looking at an OCI image index manifest list for Latestwasalie web latest, which points to 2 image manifests. One proper Linux AMD 64 image and one generic entry with architecture unknown, OS unknown. Below is how to interact with this index in each one of those manifests. Crane is a Docker orchestration tool similar to Docker Compose with extra features. For example, it offers ultra-fast, dependency-free bind mounts for Docker on Mac with a speed boost of at least 10 times. Okay, so inspect the concrete AMD 64 manifest. To see the actual image manifest for Linux AMD 64, tell docker manifest inspect to dig into that specific digest. So we do verbose. This will show you config, blob, image metadata, entry point, environment, layers list, each layer digest and size. Okay? Inspect the unknown manifest. Likewise, inspect the other entry. This often reveals a config that is not a real container image. Very small layers or config sizes, indicating that it's not a normal runtime image. So manifest, okay, so this thing, that with verbose. Manifest inspect verbose. What challenge is this? This is a challenge from HackMyVM. I'll get it for you in just a second. So this is what we're looking at here. Latestwasalie. So this is a very interesting Docker-oriented challenge. We need to interact with Docker images and inspect them and all the wacky quirks that come with that. Okay, what is this? Is this some sort of weird base 64 like encoded string? So this is a base 64 encoded string that points at other manifest entries? Oh, this is giving me a headache. Okay, so this points at something else. JQ works on that too, probably does. So we got something called provenance over at slsa.dev. This is probably some, I mean, I'm not too sure what it is. Okay, let's feed this to our good friend the AI. Maybe it can explain what the heck is going on. Okay, this manifest is not a normal container image. It's an OCI style attestation / provenance artifact, specifically an in toto SLSA provenance blob attached to the same tag as your Latestwasalie web image. Below is what you're seeing and how to interact with it. What the manifest actually is: media type, application, blah blah blah, still framed as an image manifest, but the contents are not layers and a runtime config. The config is tiny and points to a small JSON blob. This is not a normal container image config. Layers contains one layer with media type, this thing, so vndin in toto plus JSON. We've got an annotation that goes to slsa.dev. So this is an SLSA provenance attestation stored in the registry as an OCI image manifest, attached to the same tag as your web app. Okay, decoding the provenance blob. Take the digest from the layer 0 digest and fetch that blob. Fetch that blob. So how do we install? I guess we need to install Crane. Crane is not installed, but being installed with this. Do we want to install it? Sure, let's give it a try. Okay. Now it's installed, so we can run Crane. Yup. So what are we doing? Apparently, we're running Crane to fetch this thing. And then... So what you'll get is an in toto SLSA provenance document telling you what was built, how it was built, and who signed it. This is useful for security. CTF can leak CI/CD internals, build time secrets, or metadata that helps you target the build pipeline. Okay, so let's try running this command here to grab this blob, grab the blob. It's like a big rabbit hole. Accepts 1 args, received 2. Accepts 1 argument, received 2. There's a crane blob, so crane fetch. Crane blob. blob with a B. Okay, error fetching blob, unauthorized authentication required. Oh. Okay, so I need to... How do I log in with Crane then? Because this thing is protected by basic auth. Yeah, that was a typo, says OS. For sure. Log in with Crane. Okay, so Crane -- help. Insecure. Allow image references to be fetched without TLS, so we probably want to use insecure. And we probably want to log in. Log in or access credentials. So Crane auth, maybe? Crane auth. So Crane auth login. Crane auth login. I need to get an example. Data Dominatrix, hello, nice to see you. And Ira Sakai, hello, hello, hello. We're just doing like a Docker heavy challenge over here. Over at HackMyVM.eu. We're learning all sorts of stuff about Docker today. Crane auth login example. Okay, the Crane auth login command is used as part of this toolset. Standard login, log into a specific registry with a username and password. So Crane auth login, reg, something something example, username, password. So let's grab that example. Comrade Soul, hello, nice to see you. What is up? Hope you're having a good day. So we've got our username and password. It's ADM and lover1. So the specific repository we're looking at here is 192.168.212.38 port 5000. Okay. Warning, your credentials are stored unencrypted. Configure a credential helper to remove this warning. Yeah, that's fine. Okay, so now we can try fetching this blob. We can... oh, jeez. So what is an attestation file? Okay, let's try looking this up. This is something I'm not really too sure about as far as Docker is concerned. Docker attestation. Nerd? Yeah. Build attestations. So attestations describe how an image was built and what it contains. Attestations are created at build time by the build kit and become attached to the something something. Okay. Signed machine-readable metadata records that provide verifiable information about the container image. Okay, so...
Hack the planet! Hack the planet!
Thank you very much, Agent 57, for redeeming the Hack the Planet redeem. Thank you. So types of attestations, so software bill of materials, or SLSA, a record of the build process, including source code or origin, build environment, and timestamps. Nah, we don't have a nerd redeem, unfortunately. Agent 57. I'll have to add one sometime later. Okay, so what do we got? So we got platform Linux AMD 64.
It's a Unix system. I know this. It's all the files of the whole park. It tells you everything.
Is this one nerdy enough for you? Agent 57, let us know. Again, we got some extra digests here. This is an attestation. What the heck are we even looking at? Where's you didn't say the magic word. Oh, what is that from? What movie is that from, Data Dominatrix? You didn't say the magic word. You know, I should probably look it up right now. Okay, so you didn't say the magic word. The famous line comes from Dennis Nedry's animated computer program while attempting to hack the system. Oh, okay. Jurassic Park, the Nedry scene. You know what? Let me see if I can grab this sometime. Maybe I can add it to the list of redeems. But anyways, let's try fitting this into argued from the AI, because I'm pretty lost at this point. Okay, so here is the blob that we fetched with Crane. Add nerds from Revenge of the Nerds as well. Oh, you know what? That's a good idea. Yeah, okay, I'll look that up. Okay, this blob is an SLSA v1 provenance attestation for your image, produced by the Docker build kit during the GitHub style build. It's structured as an in toto statement and tells you exactly how the image was built, what it depends on, and some limited metadata about the build environment. Below is a breakdown of the key parts. Okay, so this is the container image that the attestation is about. The build source is Docker file living on the context root. Implies that the build was run with no cache, so no layer reuse. Base image fingerprint. This is pinned to a specific digest. Build kit environment, how you can use this. Fingerprint and correlate images. Given this subject digest, you can match this image against other registries or artifacts. Tie this provenance to specific CI runs. For a CTF, this tells you the base image, the build kit, the build tooling, build flags, config file. Look for artifacts and secrets around this build. CI/CD systems that remit SLSA provenance often also expose build logs, environment variables, artifacts paths. If you want to forge or modify this, dang, this is getting complicated. If you tell me what you're trying to accomplish, reverse this Docker file. Find a vulnerability in the field. I can walk you through a concrete next step commands. Okay, so I think what we really want to do hacking equals complicated. Not all the time, but more often than I'd like, huh? Does the image digest match the digest we already know? Probably. I mean, I'm gonna go out on a limb here and say probably not. So we're looking at the manifest here. this thing, it turns out, was this, what was it called? Like attestation? So we're looking at this. So inspecting the other blob, which has this information here. And when we looked at this information, it was more JSON information. Attestation and provenance. I mean, that seems like it sounds very political. So there's these other digests over here. And so these things, I mean, this is like a larger thing. We can't, I'm pretty sure we can't download any of these. Can we inspect it? $500 internal server error. Okay, so I'm pretty lost. I think I might want to take a look at the write-up for this, because I mean I could spend a long time trying to understand exactly what is going on, but I think I'm gonna take an L on this, and I'm gonna take this as a learning opportunity. So we'll go back over to here, and we'll take a look at the write-up. So Lenham has a write-up. I mean, his is in Spanish though. Let's take a look at one in English. Okay, so Latestwasalie, right. So the write-up details the compromise of a target system exposing a web application backend by a Docker registry service, sure. Internal network compromise walkthrough, enumeration, nmap. So we run nmap, we find 22, we find 80, we find 5,000, sure. Okay, we got Docker registry over here. So this redirects to latestwasalie.hmv, which we add to the host files. Okay, we identified a platform exposing a service functionality. So in the source code, we discovered the username here, ADM. So we perform directory fuzzing against the target endpoint. Okay, we find v2. So I mean, v2 we kind of inferred because we're familiar with the Docker registry API system. This requires basic authentication, and then they use Hydra to brute force the password for the ADM user. Okay? To interact with the service via command line tools such as curl, the credentials were encoded in base64. Okay? From the initial nmap scan, 5,000 is the Docker registry service. After researching the Docker registry service and its attack surface, we proceed with further enumeration and exploitation. Okay, we confirm the presence of a registry of a repository hosted in the image. Yeah. Okay, so we access the catalog endpoint. We enumerated its available tags. So available tags, just latest. So next we pulled the image locally to analyze and interact with that. Okay, authentication to the registry is required. Then we pulled the image. So they pulled the image directly. So Latestwasalie web. Yeah. And then we verified that the image was downloaded. We took a look at this last time, like in the last session we were looking at this. The container was then instantiated locally. Okay. After confirming was running, we obtained a root shell inside the container. Okay, and then at this stage we were able to inspect and modify the file system locally before pushing changes back to the remote registry. Huh. Inspect and modify the file system locally, pushing changes back to the remote registry. Initially, attempts to achieve remote code execution via PHP were unsuccessful as dangerous functions were disabled. To identify where these restrictions were defined, we searched for PHP configuration files. Oh, wow. We were going in the wrong direction. We were moving in the wrong direction with this. So what they're trying to do here is they're trying to modify the image and to make it vulnerable. To identify where these restrictions were defined, we searched for the PHP configuration files. So let's see, hardening.ini. Okay, so if we go back in, apparently we're not supposed to pay too much attention to all this other stuff we found. Okay, so there's Docker. We can run Docker run. But we're running as www data. So I mean, they've already told us about this file called zzhardening.ini. You're digging deep on a rabbit hole. I mean, I'm not too sure if I'm digging deep on a rabbit hole right now.
There's a safety locker inside of me.
Huh. Because I've never heard of this file before.
And I hold the key. It's sealed with layers.
It's a root-owned file.
Irony. What's within? I refuse to see.
Okay, expose PHP off, display errors, log errors.
I hold on, I hold on, I hold on.
Upload temp directory. Disable functions. Disable functions exec pass-through shell exec system. Okay, so if we modify this, ZZ makes it the last file included, overwriting anything before it. It's not that uncommon. zzhardening.ini. Okay, we've got ads running on Twitch, so we'll put on some birds. Okay, these are my favorite birds, the fledgling Stellar Jays. We'll be back in about 60 seconds. I just need to have a little bit of a water break.
One toss and I'll forever be blind.
Okay. Ah, these birds are so cute. Anyways, get back to the hacking. So, zzhardening.ini, so this is an initialization file. So disable these functions, exec pass-through, shell exec system. I think we can probably run Docker to give ourselves like a root, to give ourselves root access instead. So Docker run as specific user. Docker run as root. Okay. So use the U flag with the Docker run. So let's see, -- user root. PHP often just loads all the INA files from the config D through setup. So it user root. We're now the root user. Is there anything special in the root directory? Maybe not. Okay, so where was the zzhardening.ini? There's no nano. Okay. So there's no nano. Is there vi? Is there vim? Is there any text editor? There's no text editor. So how do we modify that file if there's no text editor? Sed or echo? We might be able to use like sed. There are not very many lines on this. Low level? Oh, you know what? This is a hardening file. We might, if we just delete the hardening.ini, how does that work? So session.save. Maybe we just delete this line with disable functions. Move it to .bogus. Move it to .bogus. I mean, maybe. Okay, so move this to this, but .old. Okay, and then maybe zzhardening doesn't apply anymore. Comment it out? I mean, we could comment it out. We could just, let's see what happens if we just omit the file, if we just rename the file so that it doesn't connect. So the next thing we want to do is we want to push this back up. Systemctl reload php fpm or reload Apache. So I mean, the other thing is that does this container have the web page? Depending on how it's set up. Systemctl reload php or reload Apache. Okay, so we got these directories here. Latestwasalie, HTML default. So var www latestwasalie. Check the Apache config. So we've got export.php and index.php. I mean, we could also include we could include a new file called like shell.php, which has a web shell. Let's try that. Let's just try making a file called shell.php. What was it called? Like revshells.com? Okay, and then grab the small PHP web shell. This one. Well, we also have like the system one. We'll try the small one first. Check the Apache config. Yeah, just let's just try creating this thing first. To shell.php. Okay, so shell.php. I mean, the other thing we could do just to guarantee that we've modified this is we could just add something extra to index.php at the bottom. Oh, let's skip this one. Okay, last deployment by, I mean, let's just add an extra one of these so that we know we modified it. So we're going to echo out something to index.php. Okay. So if we manage to get this to appear on the website after we push this container, then we've successfully modified the container. Alright, and what else should we do? So we need to figure out how to push the container back up to the repository. So docker push container to registry. Okay, so to push a Docker image to a registry, you must first authenticate to your local Docker client, tag your image with the registry's address, and then use docker push, authenticate with the registry. So you must log into the destination registry to ensure you have required permissions. So run docker login, okay. Tag your image. Docker images have to be tagged with the registry host and repository name to be pushed correctly. Command format docker tag, local image name, registry domain, repository name. Push the image. Once tagged, use the docker image push command to upload the image. So it's just docker image push. Thank you very much, Golden Ratio Dynamics, for subscribing on YouTube. Thank you very much. Much appreciated. Okay, so authenticate with the registry. We've done this. Tag your image. So it's docker tag. Okay. So let's get out of here, because I don't think we're doing anything else on the image. So it's docker tag, local image name, docker tag latest I'm actually not too sure what the name of this image is. So how do we get a name of the images? Or how do we get a name of all the images that we have? Sudo docker. Actually, can we run? Yeah, we're part of the Docker group now, so we don't need to run sudo with everything. Let's see, what do we hope to achieve by pushing the new image? So, if the new image is part of a CI/CD pipeline, then we can log back into the website here and take advantage of... You know, that's a good question, because even if... No. Okay. I think this is what we're supposed to do, right? So we would... Where is it? So if this Docker image is being used... Well, I mean, if the Docker image is being used to deploy the website, then if we modify the image and push it to the registry, we can enter the image from the web, and then once we've entered the image from the web, we can do a Docker escape. And then after we've done the Docker escape, then we can compromise the Docker host. So if the Docker image is being used to deploy the website, then we have to modify the image and push it to the registry, enter the image from the website, which would be doing it, what was it, via like web shell. So do initial access from the web shell, then from there try to figure out how to do a Docker escape, and then after the Docker escape is done, compromise the Docker host. That's a lot to ask for in like 9 minutes or like 29 minutes. 9 minutes or 19 minutes. So this is kind of it's kind of assuming that this is being used as part of the CI/CD pipeline, or that this image is being used to host the website. So what can we do? I mean, this is what we have right now, and we were taking a look at the write-up over there, and the write-up was talking about disabling the hardening on the PHP on the PHP engine. The other thing that we should have done, I guess, while we're looking at you can run a local running Docker image. You can run a local running Docker image. It could verify your attack. Okay, so we could run. I think so this is what we'll do. So first of all, we'll figure out the name of this thing. Docker then worry about a push after a working chain. Okay. So to enumerate a list of Docker images that have pulled to your local system, you'd use Docker CLI. So run Docker images. Docker images. So we got this one over here. Created 2 weeks ago. So this is the repository. The image ID is this. So do we run it by image ID name? Docker run this thing. So this thing exposes. So we want to. We probably want to do like localhost 5000, I guess. Localhost 80. It would be bound to like localhost 80. Okay, so now we go to could not reliably determine the server's fully qualified domain name. So using this. Okay, so we use this IP address. There's a command P to automatically bind ports. So we can access it from here. So HTTP this. Unable to connect. Actually, so if it is running from 172.17.02, we could scan it. Okay, found local port, discovered open port 8080. Oh, it's on 8080, huh. Alright, let's try 8080 then. Okay. So we can access this from 8080. And let's see. This is so heavy. Let's see if we can access the index.php. So index.php was not found. What was the IP address again? So 1720, this one. Oh, maybe we need to resolve the IP address. Hold on. That means we need to change our etc host file for a second. Okay, so let's do that again. So this will go over to Latestwasalie.hmv and enable to establish a connection to the server. So this has to be to port 8080 though. Yeah, okay, so this is port 8080. We make sure that our changes took effect by going down to the bottom. Check the vhost config in the Docker for Apache. Okay, so this wasn't modified. We changed it when we went in as the root user, but it didn't work. Huh. So the other thing we did was we made a file called webshell.php, or like shell.php, but it doesn't look like it's here. We changed it locally. So we need to find a way to change it, yeah, we changed it locally. Okay. So let's go back in locally. So Latestwasalie. We changed it locally. It looks like it didn't take effect. Huh. It reverted back. So how do we permanently make changes to the Docker container? So just going in and modifying it after the fact doesn't work. So I guess the other thing we could take a look is at the Apache configuration file. So I think the name of the file is like apache.conf, like this. No. Okay. So what is it called? Okay, so this is going to be apache2.conf. Okay. Time. Thank you. Thank you. So how much time do we have left? I mean, we could probably do another 15 minutes, and I would be okay with that. I don't want to go too long, but if we can do a little bit more progress in the next 15 minutes, that'd be great. Okay, so it's apache2.conf. Here it is, okay. And we just need to take a look inside here. So sites enabled, star.conf, sites enabled. Include ports.conf. Too long for me. Good luck, child. I'll check the last 50 minutes of the recording tomorrow. Hey, thanks, SysOS, and thank you very much for chatting over here. And hope you have a good weekend. Wait, good weekend? It's only Wednesday. Never mind. Don't have a good weekend. Have a great rest of the week is what I'm trying to say. It's been a long day, but hey, get some sleep. Catch you next time. Okay, so. Weekend that's fast, and I thought I needed to sleep. Yeah, well, it's been a long day. So can we just modify the Docker container contents by using Docker run, or do we have to do something special? Docker container. Modify image. Okay, Docker images are immutable, meaning they cannot be edited directly. To modify an image, you must create a new one using one of the following methods. The recommended way, Docker file. So this is a standard practice for reproducibility. You create a new image by extending an existing one. So Docker file, okay, build the new image. The manual way, Docker commit. This method is useful for debugging or quick snapshots, generally discouraged for production because changes are not documented to the script. I mean, maybe this is the way we want to do it. Start the container, make changes, save to a new image. In a new terminal, run docker commit container ID my new image. File transfers without committing. If you only need to update a file in a running container, without you creating a new image, use the docker cp command. Okay, host a container. So what we want to do, build from script or save container state, shell into container, copy files. So if we want to copy files into the Docker container, is this permanent? Okay. You may need to commit the editing. Save container state. So docker commit container ID new image name. I mean, we could probably commit container ID into a new image name. All right. So that means we would go into Latestwasalie and then edit the index.php. Actually, yeah, so edit the index.php. Echo, well, get this, echo to index.php. Okay, and then create our web shell file. So our web shell file is, what is it called? Rev shells. We'll just grab our small PHP web shell over there. Okay, so let's see. Webshell.php, it's here. And then we need to get rid of the security file. So I think it was called like ZZ hardening. ZZ hardening.ini. Okay, here it is. We will get rid of it. Actually, the other thing that we might be interested in is seeing where this file is referenced in other files on the file system. So we would do something like run grep recursively. You probably want to do that from the temp directory. So grep recursive on the entire file system and look for this pattern. do that, redirect into a file called harden.txt. We'll run this as a process. Okay, thank you very much for following. Jogi, hello. And thank you very much for following on Twitch. Thank you. Thank you very much. Operation not permitted, huh? Nothing's in here. What is this PHP thing? That's a directory. It's a directory owned by data. www.data. Let's take a quick look in there. There's nothing in there, of course. Alright. We didn't find anything for zzhardening.ini. Anyways, let's get rid of this file. So move this to .old, and that means that this file will no longer take effect. Actually, if it's being initialized by star.ini, then we probably want to get rid of the ini suffix there. Okay, and then I think that's all we need to do. So yeah, this is probably nothing. Exit out of here, and then do the commit. So how do we commit this thing? Save container state. Docker commit, container ID, new image name. Alright. So Docker commit this thing, and then we need to give it a new container ID. So new image name is going to be, I don't know, malicious container. Okay, no such container. So this container doesn't exist. Wait, what? No, this is the correct container ID. Docker commit, container ID, new image name. Docker commit, this ID, and then the new name. But it says that error response from daemon, no such container. It says this container doesn't exist. Okay. So let's just take a look at like a Docker commit example. Docker commit example. Okay, so Docker commit container ID or name, new image name tag. Run the container, modify the container, commit the changes. So docker commit, save this modified state as a new image. Oh. Wait. Maybe we should be using the image ID here. Okay. Alright, so let's just do like a very quick modification, just so we can see that the commit thing works, right? Echo test and make a new file called test.txt. Okay, then we'll exit, and then we'll do the commit thing again. No such container. No such container. I mean, we can... Is this the actual name of the container? I think it's kind of weird. Huh. So each time we run this, we get like a different container name. Docker images. So we got malicious container. Okay, and then we'll try running the malicious container just to make sure that the commit actually worked. Docker run, or just Docker run that thing. Docker run malicious container. Okay, and if the malicious container is running, then we should be able to access it from, I don't know, from our web browser. Docker ps. Huh. It's not running. Alright. Well, you know what? I think we might need to break here, because it's getting kind of late, but let's talk about what else we're doing this week. Okay, so this is the first stream of the week on Wednesday, but we've got another one coming up on Friday. So on Friday, we're going to be doing some AI basics, and then we're going to be doing some new stuff. We're going to be taking a look at the OWASP Top 10 for LLMs, so basically LLM chatbots. We're going to be taking a look at the vulnerabilities that exist, and well, we're going to be learning about all that over at Contra Labs. We're going to be doing a new course over at HackerFrogs. This one's going to be digital forensics. Our first session is going to start on Friday. We're going to be taking a look at the Portswigger OAuth 2.0 labs. So there's all sorts of fun vulnerabilities for this very common method of authenticating into applications. And then we're going to be doing some challenges from the HackerPol French CTF website. So that's going to be a lot of fun. Let's see if there's anybody else who is streaming right now over at infosecstreams.com. So this is a very good resource for learning about people who do cybersecurity on Twitch and on YouTube. And it looks like BlazeBits is on, so let's go ahead and give him some love. Okay, so we will raid BlazeBits. Okay, so we're going to be back on Friday, so please stay tuned for that. I hope everybody has a good week. But until next time, 5, 4, 3, 2, 1, HackerFrogs out.